Hello and welcome everyone to ZaranTech. Did you know that Java is used by over 3 billion devices worldwide? Let us dive into the basic Java programming course. Java is a versatile programming language used in mobile apps and enterprise systems. With over 9 million developers worldwide, its popularity stems from its portability across platforms via the Java Virtual Machine (JVM). Java's broad applicability and cross-device compatibility make it a key choice for developers and businesses. Its widespread use means that learning Java opens up numerous opportunities in software development. From creating Android apps to working with large-scale enterprise systems, Java skills are in high demand. In this course, we'll start with the basics of Java programming. You'll learn about variables, which are used to store data, loops, which help you repeat tasks efficiently, and methods, which allow you to organize and reuse code. These foundational concepts are crucial for building more complex applications and understanding advanced topics in Java. Before we begin, please make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us. Now let us look at the agenda. 1. Introduction to Java. 2. Java data types. 3. Type conversion. 4. Operators. 5. Conditional statements. 6. Iterative statements. 7. Methods. Let's dive in.
In this session, we'll discuss about the basic history of Java programming language. So what is the need of Java programming language, as we have other programming languages as well, like C and then C++, which are very popular programming languages even in current industry. So the objective of this session is, first we discuss about the need of Java, and second we'll see what are the basic tools which are used for application development, and then we'll see what is the installation and then configuration, and after that we'll see a Java example program, and then we'll see how to compile and then how to interpret the Java program. So to start with, what is the need of Java, or what is the need for Java programming language, even though we had very famous programming languages like C and C++. So the reason behind this is the applications which are developed by using C and then C++ are platform dependent. Example, suppose when you're developing an application in Windows operating system using C, the application always will be developed, or the application always will be given for Windows operating system format. Similarly for other operating systems, so you cannot run this application in any other operating system. So that kind of applications we call them as platform dependent applications. Especially when the internet came into existence, a lot of distributed applications has to be executed in different operating systems. So C and then C++ applications could not be able to solve this solution. So James Gosling and his team are involved in working for developing a programming application, programming language which is platform independent. So that's how they invented Java in the year of 1995. The major reason for developing Java is to develop a platform independent programming language. So the question comes, like, how Java is platform independent, or how Java applications are platform independent. So to answer this, suppose if you develop any application in C, after compilation you're going to get the output according to the operating system. Example, suppose when you're developing any C program, example hello.c, after compilation of this by using C compiler, you're going to get the operating system dependent code. Suppose hello.exe, it is according to the Windows operating system. So you cannot run this particular output or application in any one of the operating systems because it is developed according to the Windows. So it became a major problem in the distributed applications with different platforms or different operating systems. So to overcome this, Java application development and then getting the output of a Java application development involves in two steps. The first one is compilation. Second one is interpretation. So what do you mean by the compilation? Is, suppose if you develop any Java program with the extension called Java C .java. So the first step we require is we need to compile this program. So when we use a Java C compiler in order to compile this code, so Java compiler always converts your source code into bytecode. So this bytecode doesn't give you any output. It is an intermediate file which is generated by the Java compiler, and then these bytecode always will be in .class file format. So this .class file is platform independent, or this bytecode is platform independent. So whether you run this .class file in Windows or Linux or Mac or Solaris, you're going to get the same output. So but .class file never gives you output. It is an intermediate code. So again, you need to perform one more operation to get the output. That is what you call as the interpretation. So interpretation is the process of converting your bytecode into machine code. So for that, we need to invoke the appropriate JVM, or the Java virtual machine, which is called as the interpreter for Java bytecode to machine code converter. So suppose if you want to run this .class file in Windows, you have to make use of the JVM of Windows. So the JVM of Windows will read this .class file and then will give you the output in Windows application. And similarly, the JVM of Linux will read this .class file and then give the output in the Linux operating system, like that Mac and then Solaris. This is how Java become platform independent. So what are the basic Java tools we require for application development? Is we need a basic software called Java Development Kit, which we use for application development. So this JDK can be downloaded. There are different vendors who will provide this JDK, and then we are going to use the official Oracle Java Development Kit in our application development or during the training program. And then you can download this from the official Oracle site, and then make sure that when you're downloading JDK, so if your operating system is 32-bit, you have to download the JDK of 32-bit. If your operating system is 64-bit of Windows, you have to download the 64-bit version of the JDK. So once you download, so you're going to get a software like this. So JDK, I have downloaded the latest 64-bit JDK, and then installation is very easy. You just double click that, and then it is going to give you the complete instructions. You need to click next, next, next. That's it. So the default location where your JDK will be installed is in C program files. There is a folder will be created called Java, and once JDK is installed, it will ask you to configure the JRE, install the JRE also. So simply click on the next, so that JRE also will be installed. So the difference between JDK and JRE is JDK is used for Java development and JRE is used to run the environment. So development kit and then runtime environment, both are required because we are using both development and then running of our application or running environment for our applications in this training program. So make sure that you have to install both JDK and then JRE as well. So once you open JDK, it gives you a lot of folders. Inside bin, you'll find out all the basic tools which we use for application development. And similarly in JRE, you also have some kind of tools which are used for running your application. So that is how you're going to install your JDK. So once JDK is installed, the second step you need to do is the compilation. So in order, configuration. So in order to do the configuration, before that we'll see what are the basic tools which are available. So JDK is having a lot of tools which are basically categorized into two things, basic tools and security tools. And apart from that, we have a lot of other tools which you can explore. So the basic tools we require is a Java C, which is used as a compiler, Java as a Java virtual machine, which is a interpreter for running your bytecode into machine code, and Java doc is going to be an API generator of your source code, and applet viewer is used to run your Java programs inside the browsers, and jar is a tool called Java archive which is used to group all your .class files into a single file. And similarly, there are certain kind of security tools which are available in Java. Especially Java is a main source on which a lot of other development environments are built. Example, if you take an Android application development, it's purely built in Java. So most of these security tools will be used in Android application development or any other SDKs, software development kits which are built based on JDK. So the key tool and then jar signer for using security tools for encryption and then signing off your applications. So the installation and configuration, once your installation is done, then you have to set the system path. That's what you call as the configuration. In order to do the system path, or in order to configure the system path, you have to right click on your PC, go to properties and go to advanced system settings, select environment variables, and inside system variables there is a variable called path. Just click on edit. So once you edit, do not delete this because a lot of other softwares also work on this path variable value. So just click on home so that it will come to the home of the beginning of your path variable. So here if you see there's no JDK which is here. So if you want to configure this, simply go to the JDK folder, go to bin and select this path, and now come to your environment variable, and then at the beginning of this you just put it and then separate this value with a semicolon. And once you click on OK and then OK and then OK, then your environment variable is set. So how you make sure that your system is configured with Java? So for that we'll go with the command prompt, and now here we'll type Java version. So when you say Java version, it will give you what are the Java version which is involved installed in your machine, and what is the current runtime environment, and then what is the hotspot or the virtual machine that we are using for running your application. That's how your Java is properly configured. If you don't set your system variable path, then your command prompt operating system does not recognize, so you cannot compile and then interpret your codes. That is a basic installation and then configuration of your Java. Now let's see how you're going to write a basic Java program. So the Java development kit doesn't come with any editors or IDEs. So any programming language uses certain kind of editors or IDEs for application development. So editors are the normal softwares like Notepad or Edit Place, or we have lot of editors which are available online. Some of them are open source, some of them are paid version for developing Java programs. So some of them are Bracket, Sublime Text 3, and Edit Plus Plus, and then Notepad Plus Plus, and then we have Notepad. And similarly, if you're going for IDEs, the basic difference between an editor and an IDE is editor is a plain software where you can write your source file. It doesn't have any compiler and then interpreter inbuilt or any kind of development environment. It just simply allows you to write a plain Java programs. So but when you come to the IDEs, which is called as integrated development environment, so all the development environment is integrated in the software, so that compilers, interpreters, APIs, and all these tools are by default available, so that your application development will become easier. So the popular IDEs which are used for Java development is Eclipse, which is completely open source, and then Eclipse is available for different operating system with a different versions. Like you can get Eclipse only with Java SE version, you can get Eclipse with Java EE version, examples like that. You can have My Eclipse, which is paid version, NetBeans open source, and then we have Android Studio, BlueJ, JEdit. There are a lot of IDs which are available. So depending upon your company requirement or your interest, you can use any one of the IDE. But mostly 80% to 90% of the companies will use only Eclipse, or they'll configure Eclipse according to their own environment. So how you're going to write your basic Java program is here. I'm now going to take an editor called Notepad++. Now I'm going to write a new Java program. So Java is a pure object-oriented programming language. So uh, each and every Java file must contain at least one class, and don't worry about the syntax. We'll discuss about it later in clear discussions in further classes. So the basic class you're going to write is public class, and then I'm going to write hello world. And then every programming language or in C and then CPP, the execution always starts with main method. So similarly in Java also the execution starts from public static void main of string args. This is what the syntax of the method, and then we'll see what is the importance of this syntax. And in order to print any output, we have to write system.out.println. We'll discuss what is this is. So now I'll say hello world. I'm just trying to. So now I have written my first program. Now what I need to do is I need to save this. In order to save this, I'm just saving it as hello world dot java. It is always better to save your class, your file with the class name dot java. So once you have written, the second thing is you need the compilation and interpretation. As I told, in editors you never get the compilers and interpreters inbuilt. From the next session onwards we'll be using IDEs, but in this session we'll try to do the manual compilation and manual interpretation. So now if you want to do the compilation, go to the command prompt and then you have to navigate to your source file where you have created. So I have created it in cd system local data d drive classroom training material assignment workspace, and then this is where my source file contains. In order to compile, first we need to invoke the Java compiler with a tool called javac, and then we need to give our file name hello world.java. Once it gives, first it will check you it will check. Now it is saying that the file is not available here, so we'll see where exactly it is there. Assignment workspace. Now I'm going to save this file. Let me check it. So I'm navigating to that folder. This is what my file. So I'm going to cd to paste this. Now I'm going to invoke javac hello world.java. Okay, what is the file name I have given? Hello world. Sorry, there's a file name typo error. So I'm going to say the file name that what I have is javac hello.java. So you can give any file name, but it's always recommended to give the class name with the file name. Okay, when we declare the public class, it should be in a file name called hello world.java. So I'm renaming this. Now when you're compiling this with the hello world.java, now what's going to happen is it will convert your source code into bytecode. After converting, it will generate your .class file. Now if you see, we got the hello world.class file. Now what we need to do, we need to interpret this with the Java tool, Java, and then followed by the class name. So once you give, it is going to give you the output. This is how you are going to write your basic Java programming by using JDK. So the program execution always will start from public static void main of string args, and then the rule here is the source file must have at least one Java class. So without that, your Java program cannot be executed. So you cannot write only the public static void main of string args and then execute your method. You must have a class, and inside that you have public static void main of string args. So there are 3 assignments which are available for this session. Please go through it and then try to write the programs, and then there is an assessment which contains 5 questions and then try to answer them.
Alright, let's test your knowledge. Here's a question for you. What is the correct way to declare a main method in Java? Option A, public static void main. Option B, public void main, string args. Option C, public static void main string args. Option D, static void main string args. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about an important topic in basic programming, called data types. So the type of the data that we are going to use in our program is called as data type. So the question arises like, why generally we need the data? Is any application that you develop or any program that you create, so usually it will be written around the data. Example, suppose you want to write a calculator application. So in calculator application you have to perform the addition, subtraction, multiplication. Usually we perform all these operations on the numeric data, which resultant data is also a numeric data. Suppose when you're writing an application for calculating the grade of a student, then we need certain kind of data related to a student, like student name, roll number, or his individual subject marks, or some other kind of information. So in this we have some kind of character data, and then we have some kind of numeric data. So when you're developing a bank application and you need to store a lot of transactions of an account holder, so all the information usually represented in the form of data. So any application or any program is nothing but the manipulation on the data. So it is very important for us to understand that what are the data types that Java programming language supports. So every programming language supports its own kind of data types. So being a programming language, Java also supports its own kind of data types. So the objective of this session is, first we'll understand what are the data types which are supported by Java, or what we call them as primitives, and then we'll see what are the rules and regulations for working with those kind of primitive data types, and what are the different types of primitives we have, and then at the end of the session you'll have assignment and then as well as assessments. So generally speaking, the data types or the data is usually divided into two types in Java. One is primitive and second one is object. So we'll talk about objects later part. So this session will discuss only about the primitives. So generally the definition of a data type is the type of the data that we are going to use in the program is called as a data type. So it may be a primitive or it may be an object. So for this session we'll focus only on working with primitive type, and once we start object oriented programming we'll discuss about how we work with the objects. So coming to Java data types, or what we call them as primitives, Java supports eight types of primitives, that what we call as 8 types of data or 8 data types. So they are byte, short, int, long, float, double, char and boolean. So the question arises, like if you are having a familiarity with any previous programming language like C and C++, so those programming languages do not have these kind of data types or these many primitives. Now the question arises, like why Java supports 8 primitives, or we have a huge number of data types. The simple answer for this is Java is more concerned about the memory management, because any data that you use a numeric number, example, suppose I may use 10, which is a very small number. So any number that you use in your program will be stored in the memory. So to store 10 in byte sequence, in bit sequence format, it needs very less memory, maybe 5 bits or 6 bits. But when you're working with a billion number, then so we need huge memory for storing those data. So Java wants to maintain the memory efficiently, so that they want to assign only small memory for small numbers and huge memory for huge numbers. So in order to categorize that, the whole numerics are divided into 6 different types. In that, the integers are separately divided into 4 different types. One is byte, second one is short, third one is int, and fourth one is long. So byte, short, int, long, they 4 are belong to integer category. Similarly, in real category we have 2 data types called float and then double, again depending upon the range. So float will be used or double will be used. And there are 2 more other data types called character and then boolean. Character is represented with a keyword called char, which is used to store one character from universal character set, and boolean is used to store true or false. We'll clearly discuss about how these variables, or how you are going to work with this kind of data. So to simple describe about a byte, so when you want to use a numeric number or an integer number which do not have any fractional part between a range of minus 128 to plus 127, you can use that range as a byte data. So byte data type occupies only one byte of memory, so which is means what, 8 bit. So a byte is an 8 bit signed 2's complement integer, so means you may have a negatives and you may have a positives. So there is a formula for defining what kind of what is the minimum range and maximum range of a value. Is the formula is minus 2 to the power of n minus 1 to plus 2 to the power of n minus 1. So if you're seeing that the minimum value is minus 127 here, so which is minus 2 to the power of n minus 1, where n is a bit. So here n is a bit, so byte occupies 8 bits. So if you're calculating that formula, just let me show you the notepad. So the formula is minus 2 to the power of n minus 1 to plus 2 to the power of n minus 1 minus 1. So this is what is going to be the value. So here byte occupies 8 bits of memory. So if you are applying the formula minus 2 to the power of 7, whereas 8 minus 1 is equals to 7, to plus 2 to the power of 7 minus 1. So which results you is from minus 128 to plus 127. So if you want to use any number in between, byte is going to be a perfect data type for using or for representing this data, so that not too much of memory will be wasted. And if you want to use any number out of this range, then we'll go for short. Short occupies 2 bytes of memory, which is called 16-bit signs 2 complement integer. So the minimum value is, so minus 2 to the power of 15 minus 2 to the power of 15 to plus 2 to the power of 15 minus 1, which is again minus 32,768 to plus 32,767. So when you're using these variables as an instance variable, and then we'll come to that point when we are working with objects. So there are certain default values will be assigned by Java for this. So the default value for all integers is 0. So byte and short both are int type, so that the default value of them is going to be 0. So mostly byte and then short is going to be used when you are going to use small numbers. So example how we are going to define is, every variable will be defined by the type of the data that you're going to store. Example, so here if I see byte a is equal to 100, so if I'm seeing this as a syntax, the syntax always will be like this: data type and then the variable name is equals to the value. So when you're declaring a data type, only a declaration will be simple, the data type and then the variable name. So when you're declaring like this, suppose say byte b, so now when I say this, what compiler will understand is, so b is going to be a memory location, what you call it as a variable, where you're going to assign a byte data. So compiler allocates 1 byte of memory, or the JVM allocates 1 byte of memory whenever it is executing this type. So because it understands b is a memory location which represents a byte data. So byte data requires 8 bits of memory, so that 8 bits of memory will be allocated. So in order to store a value, b is equals to, now I can assign minus 128 to plus 127 or any value. So simply I can say b is equal to minus 127. So that minus 128 will be converted to the bit sequence and then will be stored in that 8 bits of memory, which is represented by a variable name called b. So whenever you want to access this b data, suppose b I'm deassigning it to 100. So then what happens? So now your interpreter will go to that memory location and then will change that bit sequence from minus 128 to plus 100. This 100 will be converted again into the bit sequence and then will be stored. So that's how we declare the variables. So if I see the examples here, I declare two variables: byte a is equal to 100, byte b is equal to minus 50. And similarly here I have short a is equal to 10,000 and short b is equal to minus 20,000. So now one more question may come when you're working with chart, because the range is minus 32,768 to plus 32,767. Now the question arises, can I use 100 to declare as a short? Yes, you can, but it is not recommended. Why? Because 100 to store the data of 100 byte variable is enough. So there's no need to declare as a short. Otherwise, if you 1 byte of memory will be wasted. So that's where you have to be very careful of using which data and then what data type is required in order to save the memory. So similarly, if you want more number, then we'll go for int. Int is a 32-bit times 2 complement integer where the range is very huge, like minus 2 to the power of 31 to plus 2 to the power of 31 minus 1, which is a very huge number. So similarly, it is a type of integer, so the default value for this is 0. So and then there's a one more important point about the int is considered as a default data type for integral values. Example, suppose if I'm representing this byte b as a byte, so when I use this b, compiler knows this as a byte. But suppose sometimes I may use only numeric data, example 100 plus 200. So in this both this case, now 100 and then 200 I'm using. So now the question comes like how the compiler treats this data. Does it treat 100 as a byte and 200 as a short? No. So both 100 and then 200 will be represented, or internally will be represented only int. So if you do not mention the type of the data, the non-integer, non-real numbers are treated as int type, not integer. Integer means byte, short, int, long. So here 100 and 200 is simply represented as int type. So because we did not mention what is a data type. Suppose if you are specifically mentioning it as a data type, then compiler will treat it as a data type. Suppose if I see here minus 128 is considered as byte only. It is not considered as int because we specifically mention this data I'm going to use as a byte. But here we are not mentioning, so by default it considers as a int. That's what the point. Now if you want bigger number than int, then we'll go for long. Long is 64-bit times 2 complement integer where the range is minus 2 to the power of 63 to plus 2 to the power of 63 minus 1, which is a very huge number. In quantrillions it will come. So there is an important point to declare about long variables. So as we discussed, like by default the numbers will be treated as int type. If you want to represent it as a long type, then you must use a suffix called small l or capital L. Otherwise the compiler will consider it as a int type only. So if you see the example here, when we have a long a is equal to some number, this number by default treats as a int type. So the range also will be within int only. So you cannot assign more than that. So but when you want to use a very huge number, then you have to specifically mention it as a L. Then compiler will allocate 64 bits of memory for this long date variable and then will store the data. So there are 4 integers we discussed: byte, short, int, long. And if you're going for real numbers, there are two different data types called float and then double. Now here also, depending upon the memory, you may use float data or you may use double data. So float occupies 32 bits of memory, what's called as 4 bytes. So the minimum value is 1.4 e to the power of minus 45, and then the maximum value is 3.4 e to the power of 38, and then the default value for this is 0.0 f. And then there is an important rule for declaring a float data. Float data must be declared with a suffix called small f or capital F. So suppose if you see here, float a is equal to 1234.567 f you need to mention. If you do not mention f, what happens is by default these real numbers are treated as double type by the compiler, like exactly how we discussed, like non-real numbers are treated as int type by the compiler, which it occupies only 4 bytes of memory. Now similarly in reals, by default the real numbers are treated as double type. So if you do not mention f as a suffix, then compiler treats it as a 8 bits of data, but there is no memory sufficient for to store it in a memory location called a, because the a is of type float, which occupies only 4 bytes. So that's where the compiler will give you an error. So If you are working with double is 64-bit real number, so where the range is very huge, and the default number is 0.0, and then double is considered as a default data type for real numbers, and then suffix is optional. So if you see in this example, double A is equal to 1234 or some data with .556 D, the D is optional, so even the second declaration is also valid. Now the other data type called char. Char is used to store a single character from a character set. So there are different character sets supported by different programming languages. If you talk about C and C++, C and C++ supports ASCII character set, which contains only 256 characters. But when the globalization happened, in order to support internationalization concept, Java supports a different character set, or there is a different character set to support internationalization concept, that is called universal character set. So all the major spoken languages in the world are the part of universal character set. So universal character set is a very huge character set which contains 65,536 characters. So all these characters will be represented by a number. So that's what you call it as a Unicode number. So this character is used to store one Unicode character or one character from an entire universal character set, and that must be embedded within a single quotes. So the minimum value is /u of all zeros and then /u of all f's. So that's what we call as 65,535 as a hexadecimal value. So the default value for this, when you are using it as an instance variable, is a space. And the declarations, if you see, the char actor data type is represented by a keyword called char. Char A is equal to, in single quotes we declare A, in char B we declare 5. Now the very important point here is to note this 5 is not a numeric data, it is a character. So because numerics from 0 to 9 are also part of ASCII, so the 5 I can store it as a character data, not as a int type. So similarly, we have one more data type called Boolean. Boolean is to represent only one bit of information. The only two possible values for this is either true or false. In C and CBP, generally 0 represents false, 1 represents true, but that is not true in Java. So in Java, we have a specific data type for storing true and false values, that is a Boolean. So you shouldn't use 0 or 1 for representing true or false in Java. That is completely wrong. So if you want to declare Boolean data, Boolean is a keyword, A is equal to true and Boolean B is equal to false. You shouldn't declare Boolean B is equal to 1. So that is what the basic data types that we have. And then we'll see a program and then can see how these data types can be created. So in our Eclipse workspace, I just created a class called data types test case. And now if you see, I have declared the byte variable byte B. This is called byte declaration. This is called B is equal to 100 is the assignment. So if I simply call this as byte declaration, and then this is what assignment. So both this declaration and assignment can be done in a single line, but that is not recommended. Example, suppose I can declare it like this: byte B is equal to 100. But according to the coding standard, this is not recommended. So usually we declare these kind of values for constants but not for the normal variables. So byte B, where B is equal to 100, and then here I'm just printing B value is equal to B. Now what happens, this 100 will be converted to bit sequence and will be stored in a memory location called B. So when I access this B again for reassigning a data for -120, then this 100 will be replaced with -120. So when you're running this program, so if you see here in the console, the first value that what we got is 100, and after reassigning or after modifying the B value, we got it as -120. So now the question here we have, suppose what happens if I declare B is equal to 130? It gives you an error. If you see the compiler is giving an error, cannot convert from int to byte. Why this why this error is coming is, so the error we are getting here is the 130 is treated as int because it exceeds the range of byte. So in order to store int we need a 4 bits of memory, but left hand side we have only 1 byte of memory. So sorry, 4 bytes of memory, but we have only 1 byte of memory. That's where the compiler gives you an error. So how you are going to declare short variables is, we can create multiple variables of same type separated by comma. Example, I can declare short s1 comma s2. So there is no need of mentioning short again. When you are using separated by comma, so compiler will understand both s1 and s2 are the type short. But you cannot declare like this. So it gives you compilation error. So you should not separate it by comma. So there you need to separate it with semicolon. So now here by short s1 comma s2, and then these are declarations and these are assignments. So I have assigned s1 value as 1 2 3 4 5 and s2 value as minus 1 2 3 4 5, and then I'm printing both these values saying s1 value is plus s1 and s2 value is plus s2. This is what you call as a variable concatenation. Now whatever you want to print as it is, we'll put within the double quotes, and if you want to assign a variable value, then we use 2 plus symbols. In between that I'll use a variable, and when I use 2 plus symbols, and again I'm concatenating one more string, and then plus I'm assigning a variable. So I don't have any other string here, so I don't use any plus here. So when you have a concatenation, prefix and suffix, you have to use a plus. Now int variable declaration, if I say int i1 comma i2, and then I've assigned the values i1 and then i2. Suppose if I give huge value, it's going to give you an error because it exceeds the range. So now i2 is equals to minus, and then I have print the value. And then if you see the long variable declaration, suppose long L1, this is what the value I have, but I don't have a suffix here. If I don't have a suffix, what it will be considered? It will be considered as an int type. So if I use very huge data, it's going to give you an error. So the error is going to be the literal of type int is out of range. That's what it understands this literal value as an int type, so it knows what is its range. So by default you can assign only an int. So there's no need of declaring it as a long. So in order to mention it as a long value, then you have to use a suffix called small l or capital L here. So when I give this value, now it supports. So that's how you declare the long data. So and when you run, and then all these values will be printed. Now if you see long L1 value and then long L2 value, while printing it won't print the suffix. So similarly, float declaration, as we discussed, float must have a suffix called small f or capital F. Now here we have float f1 is equal to this value. So I'm just printing this. Suppose if I don't give this, what happens? This compiler is going to give you an error. See, it errors. So it again says double cannot convert to float. Why? Because it is a 8 bytes of data where we have only 4 bytes of memory. So you have to be very careful when you are declaring a float value. You must have a suffix small f or capital F. So again, declaring double, you may require, you may not require the suffix. By default it considered as a double only. Now coming to character, now character data can be declared in 2 ways. One is you can directly assign the character within the single quote, or you can directly assign the Unicode number. So now if you see these two declarations, these two are valid in Java, whereas in the first one, the one numeric value is stored as a character. So here 1 is a character, not an int. But when you're saying 65, 65 is not considered as a int, rather it is considered as a Unicode number. So what compiler treats this is, the corresponding character for this Unicode will be assigned to ch2. So when you're printing this ch1 and ch2, if you see ch1 value 1 came, whereas ch2 is capital A. Why? Because the Unicode number for capital A is 65. So this will be assigned. Similarly, we have Boolean data. Boolean b1 is equal to true, Boolean b2 is equal to false. Suppose if we declare Boolean b3 is equal to 1, gives a compilation error. As we discussed, 1 does not represent false in Java, true in Java. So that's completely illegal. So when you're running it, the b1 value is true and then the b2 value is false. That's what the output you'll get. So this is how we work with the data types or with the primitives. So we have an assignment. Please go through the assignment and try to answer these questions. So how to declare octal hexadecimal numbers? Just try to explore. Apart from the decimal numbers, we have two more decimal numbers called octal and then hexadecimal numbers. Try to explore yourself how the octal will be declared and how hexadecimals will be declared, and try to answer these assignments. Once this assignment is done, you need to take an assessment which have 5 questions. Now all these 5 questions are here. So try to answer this. At the end of this, key will be given to you.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about the data type conversions. So in this session, we'll discuss about the type conversion. So means converting one type of data into another type of data. So the objective of this session is we'll discuss about what is type conversion. So means converting one type of data to another type of data. So as we know that Java supports 8 primitives, out of which 4 are integers and 2 are reals. So there are total 6 numeric data types which is supported by Java. So as we know that in even general mathematics, we need to perform various operations on different data. Sometimes we need to perform arithmetic operation on an integer type of data and a double type of data, or similarly a float type of data or a byte type of data. So like that, we usually use these kind of data types regularly for data manipulation. So when any instruction is compiled by a compiler always looks for syntactical analysis. So when it sees like the operation on a different data types, and then the resultant value will be stored of what type of data. So all these things will be analyzed by the compiler as part of its syntax, that what it calls the syntactical analysis. So in order to be syntactically perfect, so we have to convert one type of data into another type of data. So provided the type of the data is convertible. It is not like that, like any type of data I can convert to any type of data. No. So we can convert numbers to numbers, characters to numbers, because characters can be used as a Unicode numbers. So internally characters are also represented as numbers. So character also can be performed in type conversion. So but Boolean is a different data type. So it is going to use only true or false values. So we cannot use Boolean in type conversion. So like that, when you're coming to object oriented programming, and again we have a data type casting or type conversion, so of converting one type of object into another type of objective, provided there is a relationship between these objects. So you cannot convert a student object to an employee object until and unless there is no relationship. So all these type conversions we'll see later in object oriented programming, but in this session we'll focus only about the primitive conversion or primitive type of conversion. So when you say type conversion in a primitives, the primitive can be convertible. So we know that numbers can be convertible to numbers. So it means what, integers can be converted to reals, reals can be converted to integers, and because the reals and integers we have total 6 data types, and then characters also can be used as numeric data, so that we include characters also in type conversions. But we cannot use Boolean for type conversion. Boolean is a special data type. You cannot convert it into any other uh, data type conversion. So depending upon the situation, from which data you're converting to which data, so type conversions can be of two types, that is what you call as the implicit type conversion, or what you call as implicit type casting and explicit type casting. So implicit type casting is converting low memory occupied data to high memory occupied data, where it is called as a implicit type conversion. Implicit type conversion means I don't need to convert it explicitly programmatically, so the compiler itself will convert it implicitly. That's what you call as a implicit type conversion. But sometimes we need to explicitly convert as a programmer, so where compiler does not perform, that is what you call as explicit type casting. When you're converting high memory occupied data to low memory occupied data, then we need the explicit type casting. Just we'll see it with an example. Suppose here we have a byte. Byte can be converted to what? Byte can be converted to either short, either int or long, or float or double or char. So because character also we are including it. So byte is 1 byte of memory, and all these occupies more memory, so that when you're converting a byte data to short, int, long, float, double or character, you don't need any explicit type conversion. So all these things will happen as part of implicit type conversion by the compiler. So similarly, short, when you're short converting into int or high memory occupied data like long, float, double, so this can be converted implicitly. So we'll talk about char later. Here also I'll just remove this. I just want you to explore about character to byte, short and all. So now here it is implicit type. So similarly, int can be converted to long, float, double implicitly. So vice versa I will have. Suppose when I convert short to int, short to byte, then here high memory occupied to low memory occupied data. So here we read explicit typecasting. Explicit typecasting. So type conversion is a very simple one, convert of one type of data into another type of data. Whether you can explicitly declare or implicitly declare, based on that we'll declare the syntaxes. Now let us see it programmatically. I've created a class called type conversion. Now here if I say implicit type conversion, it is converting low memory occupied to high memory occupied data. Suppose if I see b is equal to 100, it's a byte data where short s is equal to b. I'm just assigning b is equal to s. First we'll think it as a syntactical analysis. Left hand side data type whatever we have is a short is equals to b. What is the right hand side data type is a byte. But if you see syntactically analysis, now the compiler will treat it like this: short variable, or what to call as a literal. It just checks what the rules for declaring a literal, assignment operation, and then right hand side you have is a byte. Syntactically it is wrong. Why? Because when you are using assignment data, assignment operation, the left hand side data type must match to the right hand side data type. But here left hand side we have short, but right hand side we have byte. So but compiler won't give any error. Why? Because compiler implicitly converts this byte b to short. So how exactly it will be done is, suppose let us run this program first to see there is no compilation error. Now when you're seeing this, the output of this value s is equal to 100, we get. So the first one, s value is 100. So what exactly the compiler will do here is, compiler will convert this into short. So whether you mention it or doesn't mention it, the compiler is going to replace this statement with short of b. That is what we call as a implicit conversion, which is done by the compiler. Or if you explicitly declare, compiler will be fine because you are doing the work of compiler, or make it very easy. So now here if you see s value is equal to 100. So type conversion is simple. To which data type you want to convert it, you just simply use the data in the parenthesis followed by the variable. So make sure that this data type should match to this. So like this. So now similarly I have int I is equal to s. Now here what compiler will do, implicitly it converts s data, which is short data, to int. So and then when I print I value, I got 100. Similarly what compiler will replace this instruction is int of s. So which is of same, so which we got as 100. So what do you mean by explicit type conversion? Explicit type conversion is high memory occupied data to low memory occupied data. Example, now I reassign the value of I to 32,000, where 32,000 is an int. So if I want to assign it to a short variable, s, if I see s is a short variable, short is equal to I. Suppose if I do this, even though 32,000 is within the range of s, you're going to get an error. Why? Because according to the syntactical analysis, left hand side data you have 2 bytes of memory, but right hand side you have 4 bytes of data. So where compiler feels I cannot assign 4 bytes of data to 2 bytes of memory. So in this case I need to inform compiler, no, this can be convertible because I know the value of 32,000 can be fit within a short. So that's why I'm explicitly converting into short. Now compiler, what it will do, now it will convert it into 2 bytes of data and then we'll assign it. So then when you're doing this, so when I say when you run this program, then you're going to get 32,000. So this is very important topic here. Suppose if I say s is equal to 130, I know 130 can be fit within short. Why? Because it exceeds the range of byte. So now what I'm doing is by byte b, which is of b is a variable of byte, b is equal to, now I'm explicitly converting it. Okay, byte of s. Now syntactically it is correct. But if I see what the syntactical analysis for this is, byte, the variable, is equals to byte. So after conversion, so syntactically it is fine. But now the question comes, when I run this program, what I'm going to get? Why the compiler is not giving the error is, compiler doesn't care whether 130 is within the range of byte or not. 130 is to be converted to byte where syntactically it is correct. That's why compiler won't give you any error. So now converting 130 to byte is a responsibility of the interpreter, not the compiler. So now what happens when this statement is executed? Now 130 has to be converted to byte, but 130 doesn't fit. So what happens is when it is converting into bit sequence, the interpreter will perform left bit operations. So it will perform the left bit operation continuously so that this 130 will be fitted within the value of minus 128 to plus 127. So when it is shifting those bytes like that, for 130 the corresponding value is going to be minus 126. So whatever may be the value you give, suppose if I give so let me run this first. If I run it, so you'll get to know that byte b is equal to minus 126. That's what you got is. So but you did not get 130. Why? Because 130 is not within the range of byte. So if I give any value, so you're going to get a corresponding number between minus 128 to plus 127 only. Now you got minus 11. So like that, it is one of the very important question in OCJP certification. So just make a note of it. The same thing will applicable when you convert integer to short. Suppose say I have given this value, which is integer, I know, but when I convert this to short, it exceeds, but it will perform the left bit operation to fix it within the minus 32,768 to plus 32,767. Now if I see minus 6,632 is a value. So that's how the explicit typecasting can be done. Now similarly we have explicit type conversions from float to or real to integers. If I see float f, I declared it as a suffix and then I have explicitly converted, whereas int can be implicitly casted to float. So after conversion, so what happens when you're converting this, the integral part will be removed and only this part will be assigned to the integer data. The fractional part will be removed, only the integral part will be assigned. So if I see after converting from float to int, I value has come like this, so the fractional part will be removed. So similarly we have long has to be explicitly long is implicitly converted to double, whereas double will be explicitly casted to long. So if I see I have created a long value, when I say d is equal to L, I don't need to put double again. Why? Because it's a implicit type conversion. When I say system.out.println of d, now the value that what we get is so 2.34 e to the power of 11, so in a fractional part. So we will put dot 0 at the end. Now As I told you, character also can be converted into integer and vice versa because it uses Unicode characters. And suppose if I use ch is equal to a, and when I say I is equal to ch, now the corresponding Unicode number for a, which is 97, is now assigned to I. So if I see I value, I got it as 97. Similarly, when I cast ch character to float implicitly, which is implicitly casted, so the value that what I'm going to get is 97.0. So this is how you perform the implicit type casting and an explicit type casting. So one data type which will not be a part of implicit type casting or type conversion is Boolean. So Boolean cannot be performed in any form of type conversions. There is an assignment given on type conversion. Please go through the assignment and try to convert one type of data type into the different types of primitives. And after that, we have 5 assessment questions. Go through each one of the assessment question, which is having 4 multiple choice answers, and try to answer them.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about operators, and in this session, we'll see how to manipulate data with the help of operators. So generally, operators are used to perform operations on the data. So every programming language supports its own set of operators, and similarly Java also supports its own set of operators. We should call it as Java is very rich in operators because it supports a lot of operators to perform the operation on the data. So the objective of this session is to understand various operators and their uses with the example. So basically Java operators are categorized according to their usages. So the first and foremost operator that we are going to discuss is about assignment operator, and all these operators are represented with the help of special characters, or sometimes a single character, sometimes a combination of two characters. So assignment operator is used to assign a value to a variable, or another variable which is holding a value to another variable. So usually the assignment operator is nothing but equal operator used to assign the data to a particular variable. And second operators we have is arithmetic operators, which are used to perform basic arithmetic operations like addition, subtraction, multiplication, division, and modulus. So other operators we have is a logical operators and relational operators, which are used to compare between two values, and logical operators are used to combine expressions, and we have increment and the decrement operators. We'll see all these operators with a set of example. So I have written a program called operators. Now first assignment operator is used to assign a value to a variable. Suppose if I use byte b is equals to 100. Now here I have used equals as an assignment operator. So b equals to 100. What do you mean by that is we are assigning 100 value to a variable called b. So the syntactical analysis of compiler will be like this: byte is equals to of byte. Why? Because this 100, it knows that within the range of byte. So compiler perform the syntactical analysis saying that this byte, and left hand side you have byte. When you're using assignment operator, the first and foremost rule that you have to follow is the left hand side data must match to the right hand side data. So if it is not matching, then we use a type conversion, which we have discussed in the previous session. So if I use short s is equal to short of b. Now here I am assigning a variable to another variable by typecasting it, or downcasting, what you call this. So this is what usually used. Assignment operator is used to assign a value to a variable or another variable to another variable. Or we have object assignment also, that we'll see in object oriented programming. So the second set of operators we have are arithmetic operators. So to demonstrate that, I have taken two variables, I1 and then I2, where I1 I have assigned some 10 and then I2 20. So even though it is not recommended, I have taken values of 10 and 20 to simple demonstration for arithmetic operations. So now if you see I1 plus I2, so here I'm using plus as the additional operator, so I'm using I1 plus I2. And now when you're using this arithmetic operator, the compiler clearly knows like on which data it can perform arithmetic operation. Example, you cannot perform arithmetic operation on boolean. So in C++ we have a concept of operator overloading, whereas one operator can be used in multiple ways. But in Java we don't have operator overloading, only except this plus. This plus is used as a concatenation operation in terms of strings that we'll see, because here also we have seen this is what a string which we are represented in double quotes. When I use this plus, it is not here as a arithmetic operator, here it is as a concatenate operator. And then but here if I use I1 plus I2, now this I1 plus I2 is arithmetic operator which performs the addition of I1 and then I2. So the compiler is very intelligent enough to identify on which data it is performing the operation. Based on that it will either perform addition or either performs concatenation. So make sure that you cannot use arithmetic operations on object concatenation or boolean data types. So it is very clear that we use it in the numerics. So now directly here I am performing I1 plus I2, or I can store this result in another variable. So when I say result is equal to I1 minus I2, here I am performing arithmetic operation and then I am assigning the result into result. So what could be the syntactical analysis in this statement is, so left hand side we have an integer data and then here I have int minus int. Okay, so there is a evaluation which is done by the compiler that any arithmetic operation, suppose say here I'm making it very clear, any arithmetic operation between integer types and integers. Example, here I'm not specifically mentioning int. So any arithmetic operation between any set of integers, like you may have byte, short, int, comma, long, and you perform arithmetic operation, and then the right hand side data you may have byte, short, int, comma, long. So any arithmetic operation between any combination of this, the resultant is int type. Okay, not integer, int type by default. So if I see here, what happens is that I1 minus I2, the resultant type is int. So the left hand side data and then right hand side data is matched. So that's what the compiler will perform the syntactical analysis. Now here result is equal to I1 into I2 or multiply to I2. Result is equal to I1 division with I2. Or here I forgot one more. Okay, division we'll discuss. I1 divided by I2. So when I say I1 division I2, now here the resultant should be 0.5. But when I run this, you will get to know that it gives you only 0. Now if you see I1 divided by I2 gives you only 0. Why? Because it always depends on the type of the data that you are performing. As I told you, the combination of any integer and an arithmetic operation with the integer, the resultant is int type. So now here 10 divided by 20, 10 is int, 20 is int. So the resultant is 0.5 and then will be converted to int, that is 0. So that's why when you are using division, you have to ensure that the numbers which are performing in division operations, either any one of that should be double or float, otherwise the resultant will be int only. So suppose if I say 10 divided by 20.0, then the resultant is 0.5. So here I am just going to demonstrate that. This is 10 divided by 20.0 plus, I'm just going to use simple arithmetic operation. So just let me run this. So when I run this, now I'm going to get 0.5, not 0. So just to be very sure, like integers and integers, the resultant type is int, and similarly any combination of reals and reals means what? Either float and double operation, float and double. The resultant is double by default. So similarly you have integers, the resultant data type is double. So this is what very important topics in terms of certification. So make sure when you are attending any interview you have to be very careful. And then there is one more arithmetic operation that is called modulus operation, so which will give you the remainder modulus I2 will give you the remainder I1 after the division. So when you run this 10 divided by 2, you're going to get 10, because 0 is the resultant and then 10 is the remainder, so you're going to get 10. So that is what arithmetic operations. So we have relational operator, which is used to compare two values. So the result of any relational operator is a Boolean value. It will result either true or false. So there are 6 relational operators we have: greater than or equal to, less than or equal to, equals to, and then not equals to. So if I see I1 greater than I2, because I1 value is 10, this 20, you may get false. Then I1 greater than or equal to I2, false. This is true, this is true. I1 double equals to I2, no. And then the very important thing, if you see I1 equals to I2, what is the value that you're going to get? If I say I1 equals to I2, now I'm not going to get it true or false. This is an assignment operation. So what happens, I2 will be assigned to I1 and then I1 gets printed. So in this case, if you see, the value you are going to get is somewhere, see here, 20. So I2 20 is assigned to I1 and then you got the print. So when you are using relational operator, you have to make sure that it should be double equals to. So double equals to will check the equality. When I say I1 double equals to I2, false. I1 not equals to I2 or not equals to I2, true. Here I need to change this. So when you run this, I1 not equals to I2, then you're going to get true. And we have a conditional operator, logical operators. Now these logical operators are used to combine more than one expression. Example here, if you are using one expression which is created by using any relational operator, example I1 greater than I2, and if you want to combine one more expression and both of them together you want to get a result, so in that case we can use logical operators which are used to combine relational expressions. Suppose if I say I1 greater than 100, ampersand is used for logical AND. Logical operators, we have 3 logical operators: logical AND, logical OR, and then logical XOR. So logical AND is represented with 2 ampersand symbols, logical OR will be 2 pipe symbol, and then XOR will be XOR symbol you'll have. So when I say how this will be evaluated is, first the left hand side the expression is evaluated, I1 greater than 100, that is false, and I2 greater than or equal to 100, this is true, but true and false always will give you false. So what is the truth table for logical AND is, you can combine n number of expressions, but logical AND always will be evaluated like this. So if you have expression 1, logical AND expression 2. So now what do you mean by this expression? Expression is one resultant of a Boolean value which is combined with a relational operator. Now expression 3, so on will have. So how it will be evaluated is, first expression 1 will be evaluated, expression 2 and then the resultant, and again expression 3 and then the resultant, like this. So the truth table for this is true and true only will give you true, and true and false gives you false, and false and true gives you false, false and false gives you false. That is what the truth table. And similarly for logical OR, we have same expression, expression 1 pipe symbol, expression 2 pipe symbol, expression 3. So what is the rule for logical OR is, if any one of the given expression is true, then the entire expression is true. So it's quite opposite to logical AND. In logical AND, if any one of the expression is false, then the entire statement is false. So if I say true and true gives you true, whereas true and false still gives you true, and false and true gives you true, whereas false and false gives you false. That is what the truth table. And then we have XOR, which is represented with this symbol. So XOR truth table is if both of the expressions are evaluated to same result, then the resultant is false. Example, true and true will give you false, whereas false and true will give you true, whereas true and false gives you true, whereas false and false gives you false. So that is what the XOR. So which is generally used to combine. So here are the expressions which we have given, and then you can see when you run this, the output is going to be generated. So whereas this is false, this one is I2 less than or equal to 100 is true, this one is false, but false or true gives you true, and then I1 greater than or equal to I1 greater than or equal to 100 is false, this one is true, so false or true gives you true. So that is what XOR. And now the other operators that Java supports is increment and then decrement operators. Now the increment operator is used to increment the variable value, increments variable value by 1. Similarly, 2 minus symbols decrements the variable value by 1. But both of these increments and decrement operators can be used in two formats, that is pre-increment, post-increment, and then pre-decrement and then post-decrement. Suppose if you see I1 value is 10, I2 value is equal to 20. Now here the value that whatever I have given, operator I have given is a post-increment. So means what? We are using increment operator after the variable. So what do you mean by this? This statement is, first it involves the value in the operation and then it increments. So when I say system.out.println I1 2 plus plus symbols, so means what? Here first it will print I1, then it increments. So means what? The output that what I get is 10 only, not 11. But after this statement it will be 11. So now let us run this first. If I run, now I'm going to get the value is only 10, not 11. Why? Because it is a post increment. So second statement you see plus plus I2. So in plus plus I2 I'm using it as a pre-increment operator. So first it increments the value, then it will involve in the operation. So I2 will be incremented first 21 and then it prints. So 21 it will print. And similarly pre-decrement. So I1 value after this will be 11. So if I say minus minus I1, what is the meaning of it? First you decrement and then you insert in the operation. So minus 1. So 10 is going to be the answer. But whereas if you see post decrement, the value of I2 here is 21. But if I am using here as a post decrement, first it will involve the value in the operation, then it will decrement. So now here the value will be 21. So it's very important that whether you are using it as a post increment or a pre increment or post decrement or a pre decrement. So based on that, these values is going to be changed. So these are the set of operators which will be supported by Java, or the general usage operators. There are other operators which will be supported by Java called bitwise operators, which are not that useful, even they are not in the OCJP as well. So this is how we are going to perform operations, or the basic arithmetic operations or relational operators operations with the help of operators. There is an assignment which contains two questions. The first one can ask you to create some 5 or 6 double variables and write a logic to calculate total marks and average. And the second one is a program, and then try to execute this program in the main method and then predict the output.
All right, let's test your knowledge. Here's a question for you. Which of the following is the correct way to create an object of class myClass? Option A, myClass obj is equal to new myClass. Option B, new myClass obj. Option C, myClass obj is equal to new myClass. Option D, obj are new myClass. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there! Want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about conditional statements in Java. Now in this session, we'll see what are different conditional statements supported by Java. As we know that Java derives its syntax from C and then its object-oriented programming languages from C++. So it supports the same conditional statements which are supported by C and then as well as C++. But it's in its own style. So the objective of this session is we'll see what are the different conditional statements supported by Java, what are its syntaxes, and then how we are going to use in our real-time scenarios. So Java basically supports two types of conditional statements. One is if-else statement and second one is just switch statement. So they both will be used for two different purposes. So switch statement is a simplified version of nested if-else statement. First we'll see what exactly is the if-else statement. So far in all our programs, whatever the statements that you have written inside the main method, so JVM is going to execute them in the same order that you have written. Example, inside main, if you have 10 statements, all these 10 statements will be executed one by one in the order that you have mentioned the statements. But in some situations, we need to execute a set of statements based on a condition. Example, suppose you want to calculate the grade of a student. So we do a lot of calculations in order to find out his average marks, and based on certain conditions, suppose if his average is greater than 70, then we say for the student grade is A. Suppose if the average marks between 60 to 70, then we can say the grade of the student is B. Similarly 50 to 61 grade, so 40 to 51 grade, or below 40 will give 1 grade. So the execution or the calculation of the grade will always be based on a condition. So if some condition is true, then we are going to say this is what is grade. If other condition is true, we'll say this is what is grade. So in these situations, we use the if-else statement. The syntax of the if-else statement is very simple. If of condition followed by some set of statements, else followed by set of statements. So here we call them is a if block followed by else block. So we'll see how this syntax will be written is. So if of condition, then we are going to define some set of statements. If you have block of statements, or what to call this set of statements as a block, if you have set of statements, then you have to group them with the help of braces. Suppose if you have a single statement followed on the condition, you don't even need these braces. Simply only for that particular statement the condition will be applicable. So suppose, and then we'll write else block with some kind of statements. So what do you mean by this is, now first compiler will evaluate this condition. If the condition is true, then it will execute this set of statements. If the condition is false, then it will execute this set of statements. Means out of these two blocks, only one block will be executed based on the condition. That is what we call as a if-else statement. So we'll see it with an example, or before that we'll see one more topic called nested if-else statement. So what do you mean by nested if-else statement? In some situations, if one condition is true, then again you need to check one more condition. If the condition is true, execute this, or else this. So like that, sometimes you need to nest the if-else statements. In this situation, the syntax will be if of condition followed by some statements, else if condition followed by set of statements. So like that, you'll have else if of condition till statement n, and then you'll have else block. So this is what the if-else ladder will call it. It's as simple as like if you have of condition. So you may have some kind of statements to execute, or directly you have one more condition to check. So, and then here you have some set of statements, and then you have some else block, and you have else here. Under else you may have if of condition, then you have set of statements, and then you may have else some set of statements, and then I'm closing else. How this will be executed is, first if this condition is true, then it will enter into this, and then again checks this condition. If this is true, then it will enter into, or if this given condition is false, then it will execute this else block. So if the given condition of the outer if loop if block is false, then it will enter into this else department, and once it enter into else, it will check this condition. So if this is true, it will execute this, or it will execute this. Like that you can nest n number of if else statements. So we'll see it with an example. Here a simple if else statement I have written. So integer number is equal to 45. I just want to test whether this number is an even number or an odd number. So the simple condition for this is, if number remainder 2 is equals to 0, then it's an even number, otherwise it's an odd number. So when you're going to run this, so it's going to say it's a odd number 45. Suppose I'll change it to 44, then the output you're going to get is even number. So that's how a simple if else will be. Suppose here if you see only one statement is there, so that's why what we don't require this. So means this if condition will be applicable to this. Okay, once you run this, so you're going to get the same output. But there is a rule you need to follow, is else must be immediately follow after if. So means with you can write only if block without else, but you cannot write else block without if. That is what the very important. Suppose if I write one more statement here, then you're going to get error. Why? Because according to the syntax, only this is applicable to if, and this will become a normal statement, and you have written else, but for this there is no if. So but when you want to write these two statements to be applicable on a single if block, then you can write like this. So that is how the if else statement will be written. So if you have a block of statements, then you group them with the braces. If you do not have block of statements, only one state, the braces are not required. That is what the very important rule you need to follow. And second very important rule is, the condition always must be evaluated to a boolean condition. Suppose if I say like number assignment 0, then you're going to get an error. Why? Because this is results in integer value, so we require a boolean value. So that is what the problem. So we have to use assignment operator. So if you see nested if else statement, now nested if the example that what we're talking about, I've directly given double average is equal to 72.5. Then I'm using my nested if else statement. If average is greater than or equal to 70, then I'm giving him a grade A. Else if, so I'm using one more condition with the help of logical operators. Average is greater than or equal to 60, and then less than 70, I'll say grade B. Similarly 50 to 60, I'll say grade C. 40 to 50, grade D. Else I'll say grade F. So here the average is 72.5. the first condition will be evaluated, so it doesn't even go to the else block. So that's why the output that what I got is grade A. Suppose if I change this to 62, then first if condition is false, so it will go here else, and then check the first if condition. If this is true, because it is true, it will print grade B, and it doesn't go to the else block. So when I run this, I'm going to get the grade B. So like that you can check. Suppose if I give 32.5, then it is going to be grade F. That's how if else and the nested if else statements can be used. And then second conditional statement which is supported by Java is switch statement. So the conditional statement, why we use switch statement is, switch is called as a choice oriented statements. So when you have lot of nested if else ladders, in order to simplify that, switch statement can be used. Means what? There will be a condition which is be evaluated to a particular value, and then there are certain kind of blocks which will compare that to the numeric value. So if that value is matching, then that particular block will be executed. That's what we call as the cases. So the switch statement will be written like this: switch of n, where n is a value. Here it shouldn't be a condition. Okay, the if statement we use condition which will follow for if, but here in switch you have to pass a particular value. So this value will be compared against the case values. So you may have a number of cases like case 1, case 2, case 3. Now exactly here case is nothing but the numeric value. Here the value may be a byte, short, char, int, or you may use enumeration, or with the help of Java 7 you can use it as a string as well. So the case, each value of this n will be compared with each case, and then the set of statements, and then if this value is matched to these case values, then that set of statements will be executed. And then we have a break statement. I'll tell you what is the use of a break statement. And then after these cases you have a default. Default is a keyword which specifies a particular set of statements will be executed if none of these cases matches with the value called n. So that is exactly the conditional switch statement. So we'll see it with an example. Now I have written a program called switch statement. Now here I have given number of days equal to 2, and where I have passed switch of number of day. Now it should be very important that the number of days should be evaluated to a value. It should not be a condition. Suppose if I give number of days greater than 5, you're going to get an error because boolean is not expected here. The only value which we can expect is byte, short, int, char, enumeration, or string class, or a character. That's it. So number of day. So now here the number of day is int type. So here for the cases I have given the integer value. So if I say case 1, so number of day is 2, so case 1 will not be matched, so it matches with case 2, so it will get prints. So let us run an output and then see what's the value or what's the output we are going to get for this program. But surprisingly, if you see, when we say that number of days is 2, it should ideally print me only it's Monday. But if you see, it has printed all the rest of the cases, including the default as well, saying invalid number. Why this happens is, so if you do not terminate the execution of a particular case block, then the interpreter will execute all the cases irrespective of the match for this particular value. So instead of doing this, we use a statement called break. So once I use break statement here, then your interpreter will come out of this switch block after executing this break. So it is very important when you are working with cases, you have to make sure the proper break statements were used. Otherwise, all the cases, irrespective of the match, whether the match is found or not, will be executed. You can use break for default statements also. So when you run now, the output will be only it's Monday, because here we have written a break statement. So your controller will stop the execution and then will come out of the block in which it is declared. Suppose here we have switch. Now the question comes, like, does break terminate the execution? No, it doesn't terminate the execution. It will just make the execution to come out of the block in which it is declared. Suppose if I write my system.out.println rest of the program, now this rest of the program will be printed after it's Monday. So why? Because break will terminate only the switch statement in the block in which it is declared. So it is very important that you have to use break in all cases of the switch statement. The switch statement also can be nested. So inside this case, you may have one more switch statement with number of cases. Inside case, you may have one more switch with number of cases. So that is exactly how we use switch statement. So these are the two conditional statements which is supported by Java. There is an assignment question on conditional statements using if-else statement. Please go through the assignment question and then try to write the program with the help of if-else statement to decide the grade of a particular student.
Hey there! Want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about iterative statements. So in this session, we'll discuss about iterative statements. So the objective of this session is to discuss about what are the different iterative statements which is supported by Java and what are its usages with the examples. So what do you mean by an iterative statement is in some situations you need to execute a set of statements repeatedly, that is what more than one time. Example, suppose you are developing an application where you are just trying to enter some students records. So you have certain kind of statements which you need to repeatedly execute while you are entering the records of the student, like enter student name, enter student roll number, or all these kind of statements has to be repeatedly executed. So in order to do these kind of repeated executions, Java supports iterative statements. So for whatever the statements we have discussed, like if else or switch statement, will be executed only once based on the condition. But here in iterative statements, a set of statements will be executed repeatedly based on a condition until the condition is false. So Java supports three types of iterative statements. One is while, second one is do while, and third one is for. So all these three are iterative statements, but their usages and syntaxes are completely different from each other. So first we'll see what is while statement. So while statement is simple, exactly like if statement. So simply like if of condition, then you have set of statements. Now similarly here you'll have while of condition, some set of statements. So what do you mean by this is, first the condition will be evaluated, and if the condition is true, then these set of statements will be executed. Once the set of statements will be executed, when it reaches the end of the brace of while statement, again it goes back to the condition and then evaluates again. So if the condition is true, again it will come. So these set of statements will be executed until the given condition is evaluated to false. So the very important thing here we need to consider as a programmer is, while you're using while statement, you have to ensure that the condition must be evaluated to false at a particular specified number of times. Otherwise it leads to the condition will be always evaluated to true, so that the while statement will be completely executed n number of times. So the infinite loop, that what we call it as. So all these statements will be executed infinite number of times, so that your program will stuck there. It never executes the other statements. So any iterative statements when you are working with, you have to ensure that the condition that whatever we give it should be a termination condition. Otherwise it leads to an infinite loop. So similarly we have one more kind of statement, iterative statement, called do while. Do while is just similar to while statement, but the main difference between while and then do while is, in while statement, if the given expression or the condition is evaluated to false, then it doesn't execute the set of statements. First it evaluates the condition and then it executes the statements. But in some situations we need it in a reverse manner. So we need to execute a set of statements first and then evaluate the condition. So until the given condition is true, then you need to execute the set of statements. So generally we use do while statements for printing menus until and unless the user wants to continue. So we use these kind of statements called do while. So the syntax for do while statement is, first the keyword we use do, and then the set of statements, and after that while the expression. So what happens is, first it will execute the statements without evaluating the expression, and for the first time when it executes, then it will evaluate the expression. If the given expression is evaluated to true, then it will enter into the do block and then execute the set of statements. If the expression is evaluated to false, it will come out. So the main difference between while and do while statement is, if the given expression is false, while does not execute anything, or it will not be executed even a single time. But if the given expression is false in do while, it will execute at least once. That is what the main difference. So in order to use a simple iterative statement, Java supports one more iterative statement called first statement. It provides a compact way to iterate over a range of values. So if you see the syntax where you'll have for the first statement is having three blocks or three divisions. Here we'll have initialization, termination statement, and then increment. So these are the three different things. So how it will be executed is, when the first statement is executed, first it will initialize the data, and then it will come to the termination condition. If the condition is true, then it will enter into the statements and then execute the statement. Once it reaches the end of the braces, then it will go to the increment department. Once increment department is done, then it will come back to the termination condition again. So it doesn't go back to the initialization again. So if the given condition is true, again it will enter. Once it reaches the end, it goes to the increment department, and then it will come back to the termination. If the given condition is true, again it will enter. Like that, the first statement will be executed until the termination condition is evaluated to false. So in all these situations, it is the responsibility of a programmer that the iterative statements must be terminated at a particular number of iterations. Okay, so all these three iterative statements can be nested. Means I can write while statement inside another while, do while statement inside another do while, and then first statement inside another first statement. So we'll see with an example. So I've written a program here called iterative statements. First we'll demonstrate the usage of while statement. Now while statement is very simple to use. Now here I have used integer I is equals to 1. While I less than or equal to 10, I'm just printing I value, and then I'm using I plus plus. So why I'm using this I plus plus is I want to print the values from 1 to 10. So every time I'm incrementing it by 1, so I'm using I plus plus. So after this statement I will be incremented, so it will go here. For the first iteration I will be 1, second iteration I will be 2, third iteration I will be 3 till 10 it will be executed. Once it is 11, condition will be false, so it will come out. So for the first time when you run this program, the output that we need to get is I value is 1 to 10. So let us see. Now you see I value is 1 to 10. So what happens if I don't use this statement? Means I value will be always 1, so it leads to infinite loop. See, it's continuously executing I value is 1, so it doesn't terminate the execution. So it's always the programmer's responsibility to terminate the iteration at a particular number of times. So it's not that you have to use only increment or decrement. You may use any operation. Suppose here I'm using I plus 3. So every time it calculates like the values that what you're going to say, 1, 4, 7 and then 10. It's like that. It depends upon your requirement. We'll use the termination condition. So the difference between while and do while is, now here we are using the same thing, do system.out.println I value, where I have given I greater than 1. So what happens, first it will print this statement, then it will check whether I value is 1 or not. So if it is greater than 1, condition false. So but the second time it won't execute the do statements. So when you run this, you're going to get output I value is 1. That is what the do value statement. So similarly, if you want to continue this, now what I can do is I plus plus. Now here I'll use I greater than or equal to, or I less than or equal to 10. Now again I'll get I is from 1 to 10. So again I got I value 1 to 10. So similarly, a simple first statement, if I use for integer j is equal to 1, j less than or equal to 10, j plus plus, and then I'm using j values j. How it will be evaluated? First j will be initialized to 1, and then the termination condition will be checked. If it is true, it will enter here and then print this statement. Once it reaches the end of this, then it will go to this department where you have incrementation. So it will j plus plus, j will be incremented to 2, and then it will come back to here, 2 less than or equal to 10, condition true, it enters. Like that the whole loop will be executed. So for is more convenient of using iterative statements. So if you're printing this from 1 to 10, you're going to get for the j values. These were the first statement. So there is one more important declaration. Suppose you may have multiple variable declaration. Example, I have integer j is equal to 1, comma, now I am using k is equal to 10. Now here I am using a single expression called k greater than or equal to 1. Now the third I am using k minus minus. Now here I am just appending, sorry, here it should be comma. So now k value is now plus k. Now we'll see what happens, how it will be evaluated. First j will be initialized to 1, k will be initialized to 10. Then these two conditions will be checked, and then the result should be either true or false. If it is true, it will enter, and then once it will execute, j will be incremented, k will be decremented at the same time. Now once you run this, now you see here that what we got is I value is from 1 to 10, whereas k value is from 10 to. So this is called multiple variables when you want to work together in a single for loop. So similarly we have nested iterative statement. So in this example we'll see how you are going to work with the nested for statement, one for inside another for. So suppose simply I have a first statement, integer x is equal to 1, x less than or equal to 3, x plus plus. Then inside that I have one more first statement, y is equal to 1, y less than or equal to 3, y plus plus. Then I'm going to print x plus same y. How it will be evaluated is, first x will be 1, the condition x less than or equal to 3 is true, then it will enter here. Then y will be initialized to 1, y less than or equal to 3, so it will execute this till y is equal to 3. Once y is equal to 4, condition false, so it will enter here. Once it enters here, it will go to x plus plus, so it will increment x value will be 2, and then here 2 less than or equal to 3, condition true, again it enters. When it enters again it will continue the loop. So means again it will initialize the y value to 1 and then check the condition and then execute. So the inner for loop will be executed every time the outer for looper is executed. So like that, the values that what we are going to print is 1 1 1 2 1 3. So this first one is x value and y value. This is x increment y value 3 times, and x is 3, y value is incremented to 3 times. That is what we have. So there are two important statements which will be supported by Java called break and continue. We have already discussed the break statement called when your JVM executes a break statement, it makes the controller to come out of the loop in which it is declared. So similarly, like how we have used in while, we can use break statement inside while, do while, and then for statement. Generally break statement in iterative statements will be used along with the if condition. So there are two formats of break statements, one is labeled and second one is non-labeled. We'll discuss about this. So in first statement, generally the label break will be used only inside the first statement. And there is one more statement called continue statement. Continue used to skip only the current iteration. So the basic difference between break and continue is break will terminate the execution and then will come out of the loop, but whereas continue will skip only the current iteration. So examples, we'll see with an example. Suppose here I'm using a condition, if x double equals to y, simply I'm just writing it as a continue. Continue means if x and y both are equal, then you skip only the current iteration. In this, when x is 1, y is 1, it will skip. Then y will be 2. So 1 and 2 it will print. 1 and 3 it will print. So again 2 1 it will print. When 2 and 2 it will continue. And then 2 and 3 will be printed. Similarly 3 1 3 2, and then when it is 3 and 3 it will continue. The loop ends. So let us run to see. Now you see 1 2 1 3, 2 1 2 3, 3 1 3 2. Suppose if same x is equal to y, if I use break, then what happens? So x and y, 1 is 1, so it will break the inner loop. So when x is 1, nothing will be printed. So when x is 2, then 2 and 1, the condition false, so it will print. So it will print 2 1. When it is 2 and 2, inner will be break. So 2 3 will not be printed, 2 2 will not be printed. Then 3 1 will be printed, 3 2 will be printed. So let us run. So we got only 2 1, 3 1, 3 2. That's what the difference between break and continue. What do you mean by label break is, suppose if x is equal to y, when I am saying break, it is just breaking only the inner loop, not outer loop. Suppose if I want to execute outer loop, I can give a label for this. outer, and then this I'm giving us inner. And now here break outer. So means nothing will be printed. So in this case, it completely breaks the outer loop. You see, nothing gets printed. That is what the major difference between break and label break and then continue. So after the end of this, we have some assignment. We are giving 5 assignment questions to you. The first question is write a program to print Fibonacci series from 1 to 1000 using while loop. And similarly, the second program is write a program to print prime numbers between 1 to 1000 using do while. And third one is, this is called as a Floyd's triangle. You have to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 exactly like a triangle. And then the fourth assignment we have is write a program to print the following output characters. Now A to F, and then it should be a mirror image, and every time it should decrease to A. The number of lines, it will be of 6, so that the output will come like this. If it is a 7, so A B C D F G, and then from G you should have a mirror image. The 5, just go through this and then try to find out what is the answer for this.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about one of the important topic in Java programming, or the basic building blocks of a Java program called methods. So the objective of this session is, first we'll see what exactly is a method, and then what are the syntaxes of writing a method, and what are the differences between C, C++ method and Java method, and what are the different types of methods we have, and we'll see an example of creating certain kind of methods, and we'll discuss about 2 other topics called call by value and call by reference with the examples. At the end of this session, you'll be having an assignment, and then you'll be having 5 assessment questions. So what exactly is a method? So method is a set of statements to perform a task. As we discussed earlier, that Java derives its syntax from C programming language. So functions are the basic building blocks or basic units of C programming or C application development. So what exactly is a function? A function is a set of statements to perform a task. So usually in C, we write all the functions to write an application or to develop an application. So, but in object-oriented programming, we never directly write the functions. Rather, we write the objects. For objects, we define the functions. That is what the only difference. So, every object will have a set of behavior. What do you mean by behavior? Suppose we said we have to calculate the grade of a student. If calculating grade of a student is a behavior, then it needs certain kind of statements to execute. So all these statements are used to perform a task, that is calculating the grade of a student. So this building block, we can call it as a method in Java. So methods are called as core components to write your business logic. So any huge application development, always we're going to implement all the business logic inside methods only. So it is very important to understand what are the different rules and regulations we need to follow in Java programming in order to write the methods. What are its correct syntaxes, how they are going to be invoked, how they are going to be executed. So working with method involves in 2 steps. First, you need to declare a method, and then you need to invoke a method to perform this particular task. So generally methods are used to manipulate the instance data. It's not required, actually it's optional. So you can write any business logic inside a method which may have instance data, which may not have an instance data. So in order to declare a method or in order to create a method, we need to follow a certain syntax in Java that is completely different from C and then C++. So Java supports its own kind of syntax, especially coming to the methods. the methods here we have is the syntax of a method. First we have is access modifier. So we clearly discuss about what exactly is the access modifier here in the next coming sessions. And second thing is a return type, and third one is a method name, the name of the method, and fourth one is a parameter list. If you want to work on a certain kind of data, you can pass it as a parameter to the method. And then the statements, which are called as the body of the method. So if you have any single statement or a group of statements, you must use these curly braces. So when you're creating a method, you must use the curly braces. Inside that you can write a single statement or you can write a number of statements. That is what a single method. So what are the different types of methods we have is, if you see closely the syntax, based on the return type and then the parameters, we can clarify methods into four formats. The first format is without return type, without parameters. Means the method does not return you any data and then it does not take you any parameter to work on. So means what? It is your responsibility to write the business logic and then execute the whole logic within a method, because it does not return you anything. So second thing is without return type with parameters, means it takes some kind of data from you and then will operate on the data and then will do the functionality within the method. It doesn't return you anything. So the third thing is with parameters, with return type without parameters, means it doesn't take any data from you as a parameter, but it returns you some data. The return type may be a primitive or maybe an object, so but it returns you something. So it cannot return huge data. It can return only one value, that could be either a primitive or that could be either an object. So the fourth type is with return type and then with parameters. So it will take the data to process and then it will return you the data also. The data may be a primitive or an object. So these are what the basic methods types. Now we'll see with an example how we are going to implement this. So in the previous example, we created a student class with only the state. We had created some instance variables. Now we'll add some more variables in order to create some kind of methods. Now for this, what I have done is I have added some kind of 5 subjects marks called subject 1, subject 2, subject 3, subject 4, subject 5. And now my logic is I want to calculate the total marks by adding all these 5 subject marks, and then I want to print. So that is what you can do inside a method. So what I'm doing is here I'm creating a method. So this is what the access modifier which I've given public, or even you cannot give it, it is an optional. We'll clearly discuss about what is these access modifiers, what are the things we can give in the further sessions. So void is a return type. When you say void, means what? If the method is not return you anything, then you have to use a keyword called void. When you're creating a method with void, it clearly tells the compiler that this method is not going to return any data. So the name of the method is calculate total marks. There is a coding standard here. If you see, calculate total marks is having 3 words. So it is always the name of the method will be camel case. So if you see calculate, the first word is completely lowercase, and then total starts with uppercase, and any corresponding word will start with an uppercase. And here there are no parameters. You see, that's why we keep this parenthesis empty. And then I'm going to write a logic. Total marks is equal to subject 1 plus subject 2, subject 3, subject 4, and then subject 5. And then here I have printed the statement total marks of the student, where I'm going to access name. So now here if you see, this is an instance method, so each instance will have its own copy. So when you're invoking this method on a particular instance, so all these values will be replaced with that particular instance values. Okay, now similarly when I say name, the instance name will be replaced here. Similarly subject 1, subject 2 will be involved. So when you're invoking this method on a different instances, each instance data will be supplied. So I don't need to explicitly declare which instance subject 1 we are talking about. So it is always based on the reference. If you're invoking it on a particular object 1, so object 1 subject 1. If you're invoking object 2, object 2 subject 1 will be invoked. So like that it is going to be calculated. So I'm just printing the total marks of the student name is equal to total marks. And similarly I have written one more method called calculate grade, but here I have a return type called char. So when I say the return type of char, this method is going to return you a char primitive. but it's not accepting any primitive, any parameters. So now here I have written average marks is equal to total marks divided by 5, and then I have used my if else ladder for calculating the grade, which I have done in the previous examples. So because this method returns a character type, here I have written at the end called return statement, and return statement specifies what type of data it is returning that should match with the type of the data in the method declaration. So if I say return grade, so this grade should be of type char. So that's how it should be. So the return statement must be at the end of this, or you can have multiple return statements if you have if statements and then else statements. So I can write return here, return here, return here, return here, return here. So there shouldn't be any return here. So like that. But ultimately I want to return the grade after the calculation. So I have written it at the end. So return grade. So this is what my state and behavior of the method. So I have created the methods. Now I will create the instance. So object creation is exactly same what we discussed in the previous session. Student1 is a reference, student1 is equal to new student. Now here object exists, object will be instantiated. Now I'm initializing the state of the student. Now student1 name, roll number is 111, department is computers, and all subject marks I have initialized to 71, and then I have invoked the method. Now method declaration, we have seen the syntax, like it is having access modifier, return type, and then the method name with parameter list, and then the body. But when this method will be executed is when method is invoked. So when I say working with methods, two steps. First is declaration of method, second one is invocation of method. So now we'll see how the method will be invoked. Now to invoke the method, because it is instance, we need to invoke on the instance reference. Now here is the student1 dot calculate total marks. So when I invoke, what happens? Now it will come to the student class and then invoke this based on the number of parameters. So now if you see the method invocation doesn't specify anything, only the method name and then the parameter list. It doesn't say access modifier, return type, because we are just invoking a method. So if it is returning a data, it will return the data to here. If it is not returning any data, it doesn't return anything. So because the calculate total marks is void, it doesn't return anything. So it will invoke this method and then execute this statement. Okay. Now the second thing is we'll calculate the grade. So for calculating the grade, it returns character. So I want to print that. So to print that, the grade of the student, here I represented student1 dot name, not only name. So if I say only name, there is no local variable actually. So it will give you an error. There is no local variable called name. But here we have used simple name. Why? Because it is instance method, so it is having all instance data available here, but it is in a different class. There is no local variable called name, so that's why we need to represent it is with student1 dot name. And then is, I'm just invoking student1 dot calculate grade. Okay, now let me run this output and then we'll see what is going to be the output. If I see, the total marks is 355 for the student1, and then the grade of the student is A. Suppose if I change all these values to 60, now let us see what happens. So I'm saving it, let me run it. Now it could be 305 and then the grade is B. So that's how you create the method and then you invoke the method. So similarly, you can create a number of objects and then you can invoke these methods to calculate the grade of each student. So it may be a student calculation grade, calculation of a grade, or it may be a salary calculation of an employee. We'll write the whole business logic inside a method and then we'll invoke it everywhere it is necessary. So it is not recommended to write the business logic inside the main method. Rather, we write it in the appropriate class method and then invoke it when and where it is necessary. That is how you work with the methods. And second one, we have a concept called call by value. So both this call by value and call by references are in terms of method invocations. Now we'll see how these concepts will vary. When I say call by value, it is calling a method by passing a value. So if you see an example, here I created a class called call by value. Here I have a method M1 where I'm passing a value called integer A. So it is not return type but with parameters. So when I say A is equal to 100, if I say integer A, this integer A is called as a local variable, So a is equals to 100. I just define this value to 100. And then I still does not know what is the value I'm going to get at the time of invocation, but it's just a declaration. So I'll say a is equal to 100. So if I was invoked, I'm just assigning the value a to 100. And then I'm just printing a system.out.println saying inside m1 the value of a is a. Now when coming to the main method execution, here I have one more local variable, integer a is equal to 10. Now the question comes, like there are two variables with the same name, how your compiler is going to differentiate, because the local variables are always owned by the method. So if I say a inside main, main is always going to have its own copy of a. Similarly, this m1 is going to have its own copy of a. So this method, when it is executing, compiler clearly knows what is a or which method it belongs to, and similarly when it is executing m1, it knows which a it belongs to. So even though the variable names are same, it is having its own copy of a. Now simply I created a local variable integer a with a value 10, and then I printed inside main a value is a. So no doubt when you're printing this, the execution happens, a value will be 10. Now what I'm doing, I want to invoke this m1. m1 is an instance method of call by value class. So first I need to create an instance, call by value cbv is equal to new call by value, and then on cbv reference I'm invoking m1 by passing this a. Now the question comes, whose a is this? This a is mains a. So the value of this is 10. So now what happens? This is called what you call as call by value. I pass the value of a. Now what happens when I pass this? The a value will be passed to the a of this m1, where I am changing a is equal to 100. Now the question comes, will this 10 will be replaced with 100? No. As I told, each one will have its own copy, so that this a will get the Xerox value of 10. It doesn't get the original value of a of main. So it gets the Xerox value. So on the Xerox value you are updating 100. So during this time only a value will be 100. But when you're coming back to the controller, when I invoke m1, what happens? The controller will go back to this m1, and then this method gets invoked, and then all these statements will be executed. And when it reaches the end, again controller will come back to the next line. Now after invoking m1, I'm again printing a. So it is not going to change the value of 10. Remember, now just let me run this. Now the values of what I got inside main is 10, inside m1 is 100 because we changed it, and after invoking m1 the value is 10 again. That is what we call as call by value. So each one is going to have its own copy. Let us see how it is going to be different in call by reference. In call by reference, the same main m1 method, now I created an instance variable called integer a. In call by value it is local variable, method variable, but here it is instance variable. Now what is the meaning of this? Each instance is going to have its own copy. Now I created void m1, but the parameter here I'm accepting it as an object, because the parameter may be a primitive or may be an object. Now here I'm defining it to be a call by reference object. Now when I say cbr.a, because I know cbr is a call by reference, I can access the instance variable on the reference. cbr.a is equal to 100. I'm just changing the value to 100. Now inside m1 the value is a. I'm printing cbr.a. Now let us see here what I have done inside main is, inside main I created call by reference object to invoke to initialize this a value. cbr.a is equal to 10. So I initialize the first value to 10. Before invoking I just printed it. No doubt here I'm going to get 10. Now if you see this invocation cbr.m1, but I pass the same cbr instance. So what happens? cbr will be passed to this. So cbr is pointing to an object now where a value is 10. Now when I pass this local variable will get the address of this, the Xerox copy. But this address always will point to the same object, right? The same object a value is 10. But now that same a value I'm changing it to 100. So what happens? At the time of invocation of this method, at the time of executing this statement, this 10 value will be replaced with the 100. Because both CBRs are pointing to the same instance. So when I print after invoking m1, the value will be 100 here. So not 10. So when you run this, you're going to get now 0, 10, 100, and then after invoking 100. That is what you call as call by reference. So there are some assignment which we have given. So try to write the programs for this.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about working with arrays. Arrays are one of the most important topics in Java programming language. So as we know that Java inherits all its basic programming concepts from C and C++. So Java inherits these concepts from its pre-programming languages like C and C++. But Java works arrays in different way. So the main objective of this session, so first we'll understand what are the ways to work with arrays and what are the different types of arrays we have, like primitive arrays, working with array of objects, with what we call as array of references, and we'll see working with multi-dimensional arrays, and we have a unique concept in Java called jagged arrays, and after that we'll see some of the examples. So how to define an array is, so array is defined as a collection of homogeneous elements. So what do you mean by homogeneous elements is the elements of same data type. Suppose when you're creating an array, you can create an array of int types, and similarly you can create an array of byte types. So you can create an array of character type. So like that, when you're grouping all these elements, the data type of that particular elements must be same. So the question rises, like, why we need arrays? Because in the previous examples we work with primitives. Like suppose if you want to declare 5 integer arrays, so simply we'll declare integer i1 comma i2 comma i3 comma i4 comma i5. So 5 variables will be created. But then what is the advantage of grouping these 5 elements into an array is, in the previous example, when you create individual integer data types, the memory will be allocated randomly. So wherever there is an address, memory which is available, so Java virtual machine is going to allocate the memory. So there will not be any contiguous memory location. So when you are accessing that element, so JVM has to search the whole address space in order to identify a particular element location. So that takes a lot of time, or when you're using a lot of variables in your application or in your program, so the performance of the application will be drastically decreases. So programming languages, especially like Java, provides a better solution of grouping all these elements into the contiguous memory locations. So storing all these elements into the side-by-side memory locations in the memory space. So when you're accessing those elements, you don't need to search the whole space. So simply you need to search the first element in the particular contiguous memory locations, and then by index-based searching, you can access all of its elements. That is one of the most advantage of working with arrays. So the arrays are of two types in Java. First, you can create an array of primitives, or you can create an array of instances. So generally, the main difference between arrays of Java and arrays of C or C++ are, so arrays are objects in Java. Java wanted to become a pure object-oriented programming language. So everything deals with the objects in Java. So arrays are represented as objects in Java. So there are steps involving in working with arrays. So there are 4 steps involved in working with arrays. The first step is, first we need to declare an array. Second step, we need to instantiate an array. That is what creation of an array. And third step is initializing the array elements. And fourth one is iterating through the array elements. So we'll see an example of working with array of primitives. So then we'll get an idea how the arrays will be created. So here I create an example program. So if you want to declare an array variables are always either prefixed or suffixed with these 2 bracket symbols. So when you're mentioning any variable of with of a different data type with these brackets, then Java compiler treats this as an array declaration. Suppose if I delete this, then it will consider it as a integer element or integer variable. But now I am making it as an array. So compiler understands here that we are going to create an array of int types. So but still here we did not mention how many elements that you are going to store in that array. So if you do not mention, the compiler or the interpreter does not understand how much of memory I need to allocate for this array. So in order to instantiate an array, we use the keyword called new. Why? Because arrays are objects in Java. So objects are always created with the help of new keyword. So I'm now instantiating I is equal to new int of 3. So in this case, what exactly will happen? When I create I is equal to new int of 3, then I will be stored as a reference variable. It's not an array, but an array will be created with the size of 3. So now this I is going to point to this, where this array will have 3 memory locations that are I of 0 and I of 1 and I of 2. So now if you see this, now the size of the array what we declared in our program is 3. So the interpreter understands 3 integer elements has to be stored. So 4 into 3, total 12 bytes of memory will be allocated for this integer variable, and then there will be 3 different locations. So now this first location is identified with an index of 0. So array index always start with 0 to n minus 1, where n is the size of the array. Now the index starts from 0. So I of 0 is the first int element, I of 1 is the second int element, I of 2 is the third int element. So because array is stored in heap, by default all these variables are initialized to 0. So there's a default value. So when I'm trying to print, so I of 0, the first index value, now I'm going to get 0. So when I run this, I'm going to see the output. So if I see the first output, that what I got is 0. So because these elements are stored in heap, so they are by default initialized with 0 values because of type int. So then we have array initialization. How we are going to initialize? So each and every memory location we are going to invoke. I of 0 is equals to 10, I of 1 is equals to 20, I of 2 is equal to 30. Suppose if you did not initialize any one of this, the default value will be 0. So now the fourth step is iterating through the arrays. So how we are going to iterate? We can use different approaches for iterating an array. We can use normal while loop or do while loop, or a for loop, a normal for loop. But Java 1.5, from Java 1.5, there is a first statement which can be used to iterate through the arrays. That is what we call as a for each statement. So the syntax of the for each statement is very useful, and for each can be used to iterate all elements in an array. Suppose if you want to access only 1 or 2 elements, you should always represent it with the index. So but when you are trying to access all elements in an array, so the better approach of accessing all the elements is using for each. So what is the syntax of for each is? For each is very simple in declaration. For int of x. So why I have used int is the data type of the array. So because here the I is in type int, so I have used int. Suppose if it is a char, I have to use a char. So appropriate data type x in I. If you use x, I didn't use any array symbol here. Why? Because the meaning of this statement is for each integer x in I. Why? Because I is going to have only int type, not integer array type. So there is no concept of integer array. There is an array of int types. So each element in I is a type of int. That's what we are declaring. For each int x in I, I'm just going to print x. So now what happens? The compiler itself will iterate from 0 to n minus 1. Here I don't need to worry about the size. And then by default all variables will support a variable called length, that gives you the size of the array. Suppose if I print size of the array, so simply I can say I dot length. Okay, now length is a variable here. It is not any function. So when you're going to write, it is going to return you the size of the array is 3. Now how we are going to iterate? Now iterating using for each statement. Now if you print the output, now the values that what I got is 10, 20, 30. So each time the index will be incremented by the program itself, and then I of 0 will be assigned to x, I of 1 will be assigned to x, I of 2 will be assigned to x, something like that. So now all the values will be printed 10, 20 and then 30. And there is one more representation of working with arrays. So instead of using array declaration, array instantiation and array initialization, all these 3 steps can be done in a single step. That is what I call array in a single line declaration. So how we are going to declare an array in a single line is, so simple character ch, here I am going to represent an array of characters. So with an array symbol is equals to, now directly I can use these curly braces. Within the curly braces I can mention the characters, because characters needs to be embedded within the single quotes. Now I've used A, E, I, O, U. Now even if you want to test this, I'm just simply size of char array is plus ch dot length. So when I'm trying to print this, it is going to give me size of 5. See, size of the character array is 5. And now we are going to iterate again for each statement. For each character C in ch, I'm going to print C. So the output that what I got is A, E, I, O, U. Now this is how you're going to work with array of primitives. And similarly, how you work with array of primitives, we have a concept of working with array of instances. What do you mean by array of instances? Is similarly like how you have array of primitives, we can group all the objects together to work with array of objects. Now suppose when you're working with student objects of 10, so instead of creating them as individual objects, we create an array of students with a size of 10, where each student will initialize with a constructor and then we'll access the parameters. So if you see student here, the working with student object or an array of student instances is a bit different from how you work with individual student objects. Now here I am making a student array, student objects array, student s is equal to new student of 3. But when I am mentioning this, now student is a type here. Here I am not mentioning it as a primitive, int, boolean or whatever. I am mentioning student. So when I say student with an array symbol, compiler understands that we are going to create an array of references of type called student. So is equals to new student of 3. If you see here, we are using this square brackets with a size implementation. So we are saying 3. Now what happens? S will be a reference to an array of student references, where it is going to create an array of 3, size 3, where each of these index will be represented with s of 0, s of 1 and then s of 2. But what will be the values will be stored inside s of 0? What is the type of s of 0? Is a student object. S of 1 is also a student object. S of 2 is also a student object, but we did not initialize them, so that by default they will be initialized to null. So if you want to initialize them, how we are going to initialize? S of 0 is equals to new student. Now here I am instantiating a student instance. So by invoking the constructor, you may use no argument constructor, you may use argument constructor for invoking each student object by using whatever the constructor you want to instantiate. Now in the second diagram, when you instantiate these 3, then s of 0 will point to student object, s of 1 will point to a student object, s of 2 also will be point to a student object. So this is the way of working with array of instances. So array of instances means first you need to create an array of references, then each reference you need to instantiate a particular object. So we'll see an example program. So here I created a class called student. Class student. I have only one property called string student name. So I have used my constructor by passing student name. So I have initialized this variable, this dot student name is equal to student name. Now in another class, in array of references inside the main method, now I created a student array reference. So students is equals to new student of 3.
So now if I want to access any of the student name, suppose the index will start from 0. So now I want to print student of 0 dot student name. Now here you don't get any compilation error. Sorry, students. Here you don't get any compilation error, but you're going to get an exception. We'll discuss about the exception later. So it says null pointer exception. Why? Because if you see this diagram, you'll get to know. Now S of 0 at this point is null. It doesn't point to any student object. If it points to student object, then only we can access the student properties. Otherwise, we cannot access. Because S of 0 is null, you cannot access the student object. So that's what you are going to get the null pointer exception. So how we are going to initialize a student object? Now here I am going to initialize student of 0 is equal to new student of student 1, and similarly student of 1, students of 2. Now I created 3 different objects which are referred by this. And the question comes like, how do I iterate? Same like how you iterate with the primitives, but here we mention the type of the instance. So here the type of the instance is student. So for each student S in students, now I'm just printing hello S dot student name. So when you're going to run this, so it is going to access all the student objects, and then we are going to access their parameters. So student name. This is how you work with the array of references. And similarly, there's one more concept of working with arrays is called multi-dimensional arrays. So now we'll see how multi-dimensional arrays will be worked in Java. So far whatever the arrays we have worked with, that is single dimension and that is array of primitives and then array of references, they both are single dimension. They are not multi-dimensional arrays. So Java supports multi-dimensional arrays also. So how it will be implemented is, it will be implemented as an array of arrays. Suppose example, if you are working with 2-dimensional array, how are we going to declare int 2 dimensions I is equal to new int of the first dimension and then the second dimension 2 of 3. In this case what happens, I will be a reference which points to one array with size 2, I of 0 and then I of 1. So because the first dimension we mentioned it as a 2, so it points to an array where there are 2 locations, I of 0 and I of 1. It doesn't store any values here, rather I of 0 will act as a reference to point to one more array of the second dimension. Now what is the second dimension here is 3. So it points to an array of 3 dimension where the index is referred as I of 0 of 0. So if you want to access this location, it will be accessed by I of 0 where it is pointing to an array of 3 size. So I of 0 of 1, I of 0 of 2, and similarly I of 1 will point to one more array of size 3. This is I of 1, 0, 1, 1 and then 1, 2 are the indexes. So if you see the example, multi-dimensional arrays will be like this. So here I created integer 2 dimension with the 2 dimension integer 2, 3. Now by default all the values will be zeros because they'll be created on heap. So how we are going to initialize the elements? So 2 dimension 0, 0, the index, I have initialized the value 10, 0, 1, 20, 0 to 30 and 1, 0, 40, 1, 1, 50 and then 1 to 60. But the question comes like, how do you are going to iterate using for each statement? Because you have 2 dimension, you need nested for each statement. First outer for each statement should have integer I, because in each 2-dimensional array first I have is a single dimension array. So inside that I have for each integer x in I. So what happens in this 2 dimension, for the first time I of 0 will be assigned to I. So our 2 dimension of 0 will be assigned to I. 2 dimension of 0 is what? Another single dimension array with size 3. So now this I will point to an array of 3 where each one of these element in this array is an int type. So I'm just referring integer x is I is equal to, I'm just going to print system.out.println x. So when you're going to run this, so now you're going to get an output 10, 20, 30 and 40, 50, 60 because I have used system.out.print here, and after the first iteration I'm printing all the elements in the second. So that's how the multi-dimensional arrays will be implemented in Java. So there is one more concept in Java called jagged arrays. The main difference between multi-dimensional array with a fixed size and jagged array is, in jagged array we did not mention the second size. Means what? The second dimension will be of varied sizes. You can have a dimension of 2, you can have a dimension of 3. So if I see I have 0 is equal new int of 2, I have 1 is equal new int of 3. In the previous example, both of these locations are pointing to fixed size element of 3, but here we are now splitting them into different sized arrays. So I have 0 is pointing to two elements array. I have 1 is pointing to 3 elements array. That is what to call as a jagged elements. So we have given 5 assignment questions working with arrays. Now write down all the programs for this assignment, and then we have an assessment test also which contains 5 questions related to arrays. Try to answer them.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about a topic called strings. String is one of the important topic in Java. Usually, in most of the application development, we use strings as a basic data that we use in our program. So far we have seen a different data type to deal with the characters that is called character primitive, which is going to store only one character. But in general applications, we use more than one character for representing the data. Example, employee name or a student name or a company name or company address. So there are different data which you are going to use in day-to-day life is more than one character. So primitives doesn't support more than one character. So we definitely need a string, a class which represents, or we need a mechanism which represents more than one characters in Java. So that's where Java created a predefined class called string to handle Java. So the objective of this session is we first discuss about what are the different types of strings we have, called string, string buffer, and then string builder. These are the 3 predefined classes which will be provided by Java API. And then we see how the string will be stored in the memory. So that is what string memory allocations with some examples. As we discussed, like string is a sequence of characters. So if you want to use more than one character in Java, you have to represent it as a string. So Java wanted to become 100% pure object-oriented programming language. So everything it deals as an object. So string is also as an object. So if you want to create an object, you should definitely have a type, or what you call as a class. So for that, Java gives a predefined API. In that we have a predefined class called string. So what exactly is an API is, API stands for Application Programming Interface. So what exactly is Application Programming Interface is? So any programming language by default provides some default functionalities to the user. So I don't need to write logic for everything in a programming language. The most common use functionalities are by default given by a programming language. So the only thing is we need to access them. So if you see, C is a collection of header files, and similarly C++ is also a collection of header files. So these header files will have all the predefined functionalities in it. So that's what we call as the functions. So whenever you want to invoke a predefined function given by C or C++, the simple thing is we include those header file in our program and access the function of the particular header file. Similarly, Java follows its own way of giving default functionalities. We do not have direct functions in Java. Rather, functions are embedded inside classes. That's what we call as the methods. So these classes are categorized and grouped under a concept called packages. So Java comes with a set of packages. Each package will have its own set of classes and interfaces, and including some exceptions and all. So to deal with, so if you want to know what are the predefined classes or what are the predefined methods and constructors which are supported by classes, then Java comes with an API. So each version is having its own API. Like the latest version of Java is 8. So Java is 8 is also having its own API. So these APIs are open source or can be directly downloadable from the official site of Java. So or even if you Google it, you're going to get it. Now simply, so if you type as Java API, so you're going to get it. Here we are going to represent the version 7. So when you're going to see this could be the view. This HTML document is divided into 3 different parts or frames. The first frame defines all the packages which are available inside Java Standard Edition. So some of the packages starts with Java as a prefix, some of them with Java X, and all of them are categorized, some of them with org. All of them are under this frame. So if you want to see or if you want to go to a particular package, then you need to click any one of the package. So the java.lang is called as a default package in Java. We'll discuss what is the default package. So once you click on that, the second frame will change. It shows what are the interfaces, what are the classes, what are the enums, exceptions which are available inside this java.lang package. So as we are saying, string belongs to java.lang package. So if you are going to see under the classes, if you see this string, if you click on that, the right hand side frame will give the complete description about the string. Now it says what is the class name, to which package it belongs to, and then what is the inheritance architecture, and then all the interfaces that your string will implement, and then the complete signature of your string class. So public final class string, extends object, implement serializable, comparable, and then character sequence. And then some description about the string, how to use, what is the need of, and then since what version the string class is available. So it is available since JDK 1.0 in the initial release of Java. And here if you see what are the constants that we can use and what are the constructor summary. So every class will have a number of constructors as we discussed earlier. So because string is a predefined class, so we should know what are the constructors which are supported by string. So in this API, you'll get to know all the string constructors and their description. So if you want to initialize an empty character sequence, we have to use this, a byte array which takes as a parameter and then converts it into a string. So like that, all these are available. So you can use any one of the constructor depending upon your requirement. Suppose if you want to convert an array of bytes to a string, you directly have a constructor. Similarly, you have an array of characters to convert a string, you have a constructor. Similarly, if you want to convert a string to string, you have a constructor. So like this, you can use any one of the following constructor to suit your requirement. And as a second thing, it specifies the methods. So every class will have its own methods, as we see in the previous programs. So what are the predefined methods which are available in the string class are described here under method summary. So as we know that the signature of the method is defined. So if you want to invoke a method, what are the things we required? We required a method name, what are the parameters we need to pass, and what is the return type, or what are the modifier you'll have. So similarly, the string class have instance specific methods and as well as static specific methods. So here the caret, which gives you the character to specified index, so can be accessed caret, which returns you the character primitive. Like that, you have all the methods like compare to, ignore case, concat. So if you want to see the description about it, just click on the link provided by that, so that it will give you the complete signature of the method, and then it will give you the complete description, what it returns, what are the possible exceptions it can throw, and all the methods explanation will be here. So that is what the introduction to API. So if you want to go to any one of the package and any one of the interfaces, it's going to give you the detailed explanation about it. So if you want to see any one of the class or any one of the interface, so first you can go to the API document and then you can access what are the classes which are available, and then what is its, some of the predefined examples also will be given by Java, so you can go through that and then you can have. So now our intention is, now in this session, is to work with strings. So let me go to java.lang. And then I'll access here a string. Now see syntactically how strings are going to be created. As we have seen, like we can use any one of the constructor for creating a string. Now let us create the string instances. So here there are two ways of creating a string, what you call as a string object, invoking the constructor using constructor, and second is string literal. What do you mean by string literal is directly we can assign a string. String always represented in double quotes. So now here I'm using string str1 is equal to new string of string1 str1, and similarly string str2 is equal to new string of str2. Now what happens? Now the Java virtual machine is going to create two different string objects which is referred by str1 and then str2, and then the content of this is string1 and then string2 representative. So there is another way of creating a string object that is called string literal. Means what, directly you can assign a string value to a string reference. What is the difference between string object and then string literal is, string literals, whenever you want to, if you already have a string literal with the value, so it doesn't going to create any object. Example, suppose if I say string1, it is going to create two different objects with the same content. But in string literal, it is not going to create two objects, rather only one object will be created, and both of these references will point to the same object. That is what the difference between a string literal. Now let me run this, and then I want to print string1, string2, string3, string4. So simply you are going to get the values. So here are the values. So you got string1, 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 string1. But how many objects will be existing by this time? Only 3. 2 for str1 and str2. One is for both str3 and then str4. That is what the literals. And then how we are going to invoke the methods is, if you see the API, you will get to know how you are going to invoke the methods. Suppose if you want to invoke caret, so it is instance specific. So you definitely need an instance. So here it say str1.caret of 2. The integer number I am passing, 2 is the index. So string index always starts with 0. So if I say 0, 1, 2, R will be the character at the index 2, which will be written by caret method. So because caret method returns you char, so I can assign it to a primitive. Char ch is equal to str1.caret of 2. So if this method does not return anything, then you shouldn't assign it to anything. So that description will be available in the API. So when I print ch, now I got R. And similarly, you have a method called compare2 to compare one string with another string lexicographically. Means what? With a Unicode number it will compare. If I say str1.compare2 of str2, because the content of them, both of them is same, then you are going to get 0. Why? Because there is no difference in the Unicode. Suppose say if I say it as 2, then there will be some difference. So the difference between character 1 and 2 will be written. That is what? -1. So like the compare2 always will return you an integer value which compares two strings lexicographically. If you want to see the description also, the Eclipse IDE is very intelligent enough. So when you move your mouse over to a particular method, so that method complete description will come. So you can see the method, and then you can also see how it is going to be invoked. So the concat, one of the very important method. So to concat one string to another string, simply we use str1.compare2 of str2. Concat of str2. The concatenation will return you one more object that I'm going to print. Now when I'm printing it, now the value that what I got is str1, which is concatenated to str2. But after concatenation, when I print str1, now I got only str1. Why? Because str1.concat is going to create a new string object. Rather, it is not going to modify str1. That's why string objects are called as immutable objects. So if I make a point here, string objects are immutable. So means you cannot modify once you create. If you are going to do any modifications, JVM will create another object, so which you can refer it. So in this case, str1.concat is going to create a new string object. So once we print them, the value that what we get is a concatenation. But when I print str1, then you are going to get only str1 because it is an immutable objects. So like that, you can invoke any one of these methods according to your requirement. There are a lot of methods, very important methods, which you can check equals, which will check content. So compared to always will check lexicographically, but it will compare the two strings with the specified objects and then both character wise. If they are true, then it will give you, if they are equals, it will give you true. If they are not equals, then it is going to give you false. So similarly, like that, you have two uppercase, two lowercase, is empty, the length of a particular string. So suppose if I print the length of a particular method, Cisco particular string, length of a string. Now simply I'm going to call str1.length method. So there is a variable called length which is used by arrays, but length is a method which is used by strings, which returns you the size of the string, which is 5. So like that, you can invoke any one of the method according to your interest. Okay, that is what working with strings. And similarly, there is one more type of string which can be given. Now this is what the string memory allocations. As I explained you, like str1, str2, and then str3 of str1. Now in this case, I'm just using reference assignment. So what happens? str1 is assigned to str3. Now both of them will point to the same instance where the value is str1. Now str4 is equal to str1. This is what the string literal. So it will be stored in a separate memory location called literal pool. So there is one more type of string which is called a string buffer. So string buffer objects are similar to string, but they are mutable. So we have seen an example like string objects are immutable, meaning what, once you create a string object, it cannot be modified. So that's where a lot of memory will be wasted on the heap. But string objects are mutable. So if you perform any operations, then the operations are going to happen in the same object. So the example for this, if you have, see, I have created string buffer sb1 is equal to new string buffer by passing str1 as a parameter. If you want to see the description of string buffer, so you can go to the API. If you click on string buffer, it is going to give you all the constructors which is supported by this. So now here I'm using the string buffer of string constructor to create a string buffer, and it is having all the methods. So it supports most of the strings method, and it is having its own unique methods which you can invoke in order to work, like insert, replace, reverse, delete, append. So these are the different kinds of methods which are unique in string buffer compared to string. So now I created two strings, string buffer instances, sb1 and sb2. Now I simply used sb1.append of sb2, and then I've used sb1, and then I'm printing it. So when I'm printing it, the sb1 value, I got str1 concatenated to str2. This way we can say that string buffer objects are mutable. So the main difference between string and then string buffer are, string objects are immutable, whereas string buffer objects are mutable. Similarly, all string A class methods are unsynchronized, means what, they are not thread safe. Whereas string buffer methods are synchronized, means what, that they are thread safe. We'll discuss about what is thread safe more detail in thread programming, but string buffer threads are methods are thread safe. So the combination of this will be another type of string, that is string builder. So the string builder objects are mutable again, but are not synchronized. So this always offers a better performance and then the simple code when you're working with the string builder. So string builder is same kind of string buffer. If you want to see what are the constructors which are supported by this, and then string buffer is introduced in 1.5. So it gives you complete constructor set, and then what are the methods that you'll have. Most of the methods of string buffer and then string builder are same, but the only difference is string buffer methods are synchronized. That's what what you say is thread safe, but string builders are, methods are asynchronous. That is what the only difference. So you can use either string or string buffer or string builder in your project depending upon your requirement. So we have an assignment. Try to go through the assignment and write 5 programs.
All right, let's test your knowledge. Here's a question for you. What is the default value of an int variable in Java? Option A, 0. Option B, 1. Option C, null. Option D, undefined. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there! Want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about one more object-oriented programming feature of Java called abstraction. So abstraction is one of the very important feature of object-oriented programming languages. So we'll discuss like how Java supports this abstraction. So the objective of this session is we'll see how abstract classes and then abstract methods can be declared in order to support abstraction in Java, and what are the implementations and how you're going to work with inheritance in abstraction, and what are the rules you need to follow for abstract classes and abstract methods with some examples. So first, what exactly is abstraction is? The basic meaning of abstraction is hiding the implementation details. So you're abstracting something, so you're not showing the implementation details to the outer world. So the question comes like, what exactly is the meaning of hiding implementation details? So in general, we'll discuss this with an example. Suppose we'll take an example of a car class. So car is having a method called body description. Okay. Now generally there is no car existing in the world. The instance of the car is existing. Example, you have a BMW car or you have an Audi car or something of that object is existing, but there is no car existing in the world. Try to understand this basic difference, because we can see only objects of a particular type. So whenever you see on a road, you either see a BMW car or you see an Audi car or any instance of a different car, but there is no car by default. So suppose when I declare a car as a superclass or a base class, and then I have a method called body description. Now we know that every car will have its own body description. So the shape of the car, and then the type of the car, the number of wheels of the car, number of doors. So there are a lot of description we can give for a body for a particular car. So if you analyze, if you're declaring car as a base class and then body description, there is no meaning of providing the implementation for it. Why? Because each one is having its own different implementation. So BMW's car body implementation is different, Audi car body implementation is different, and others cars body implementation is different. So suppose, what is the point of providing the body description inside the base class? There is no meaning actually. So that's why Java, these object-oriented programming languages introduced a feature called we will hide the implementation details. We'll ask our subclasses or the implementation classes to provide the implementation for this method. So it's just like a contact. It just tells what to implement. It doesn't tell how to implement. The how is the body of the statements, body of the method. So that implementation will be provided by the implementation classes. So generally the abstraction in Java can be achieved by using either abstract classes or abstract methods. So to implement abstraction, we use abstract keyword either to declare it as an abstract class or an abstract method. So first we'll see what are the example of an abstract class. Suppose here I have taken car as a base class and then I declare it to be abstract. So what do you mean by this class I am declaring it to be abstract is I want to hide the implementation of body description method and then engine description method. So but if you see, this car is having some instance variables exactly like the previous examples whatever we have seen, like it is having int number of wheels, string car type, string engine type, and then it is also having a constructor called car with these three parameters. So I'm initializing them. Okay, but it doesn't have any normal methods or the instance methods. It is having only abstract methods. So abstract method, what is the difference between a normal method and an abstract method is an abstract class can contain normal methods also. So example here I'm giving void um, body description, and then let us say I'll give door description. Now I want to provide the implementation for it. Now suppose say if I write any logic inside this, so it is called, this method is implemented, it is having a body. So any derived class is going to access this door description, it is going to get the same body which is implemented inside the car class. So door description of car class. Now in the previous session we discussed how to overload this, how to override this, and then how to be accessed by using its derived classes, and all these things we have discussed. So exactly the same concept will work here, but for some of the methods there is no meaning of providing the implementation. We'll ask its subclasses to implement these methods. So here it is a normal instance method, now here it is an abstract method. So when you're creating a method to be abstract, it should not contain any body. So suppose if I delete this, now you're going to get an error because there is no body for this method. So you cannot uh, create a method without a body without using abstract. So now here I'm going to call it as a abstract. So when I say abstract, it should not contain any body. Suppose if I say if you give any body, and again it is going to give you an error because abstract should not contain any body. So all the abstract methods will not contain any body, and then they'll enter with a semicolon. Now the question comes, does it a method invocation? No. In method invocation, simply what we do only the method invocation with method name and then the parameter list. We don't declare the return type and then the access modifier and then the abstract. So that is what the difference between a method declaration and method invocation. So abstract methods always will be declared to be abstract. There is one rule here. Suppose if your class class is having at least one abstract method, then you must declare your class to be abstract. Okay, the rule you have to understand it very carefully. Suppose say I did not declare this class to be abstract, so what happens, I'm going to get an error. Why? Because you have to declare this car class to be abstract. Why? Because it is having two methods. Suppose what happens if I don't have these two methods. Now I may declare this class to be abstract, I may not declare this class to be abstract. Now you see here I did not get any error, but still the class is abstract, it is not having. So the rule here is, if your class is declared to be abstract, it may have any abstract method, it may not have any abstract method. Okay, the second point is, suppose if your class is having abstract methods, you must declare the class to be abstract. That is what the rule you have to follow. So now let us say I have my abstract class car and then I have two abstract methods. Now the question comes, who will provide the body for this? So for that I'm creating two subclasses or one subclass called Audi extends car. Whenever it extends car, then immediately you're going to get an error saying that you have to provide the body for all unimplemented methods. So if I say that unimplemented body will by default come, signatures by default come by the IDE, but I have already provided it. Now you see the body description, one second, body description and then engine description. Now here I am providing, suppose what if I don't provide this constructor. Now again the concept will vary. Now what happens here, in your car you have argument constructor, but here you have no argument constructor, that is calling to no argument, but here you have an argument. So it will give you an error saying that you have to add the constructor with these three parameters. You have to add, otherwise it is going to give you an error. So I have added these constructor which is having string int and then number of wheels and then the engine type, and then I call my superclass constructor. I don't want to initialize it because I have already initialized here as a superclass, because these properties are belong to superclass method. So here if you see in RD, I don't have any variables at all. I may have my own variables, but all these variables are my superclass variables. Now here simply in body description, I'm just printing them, RD car body description and then the car type and then the number of wheels. Similarly, I created one more implementation for car called BMW. It is also having a same logic. So I have a constructor and then I pass these three values and then I'm printing BMW car description and then BMW engine description. Now we'll see how we are going to instantiate them. Now I created RD is equal to new RD by passing SUV as a car type and the number of wheels is 4 and then the engine type is petrol, and then I invoke body description, I invoke engine description. So similarly I instantiated BMW sedan by passing 4 as a number of wheels and then diesel as a engine type, and then I invoke body description and then as well as engine description. So once you run, you're going to get the output. So you see here, first you got Audi car body description, car type is SUV, number of wheels is 4, and then Audi engine description, engine type is petrol. And after that we invoked BMW's car body description, whereas car type is sedan and number of wheels are 4. And after that BMW engine description, engine type is diesel. So the meaning of this is abstraction. When you create any abstract class, the implementation classes has to override all the abstract methods. Suppose what happens here, I don't have RD, I have RD, but I don't want to provide engine description. I want to provide only body description. Now in this case, it will ask you to two things. One thing, you can either implement the method or you can make it abstract. But once it is abstract, you're going to get an error in your abstraction test case. Why? Because abstract classes cannot be instantiated. Here you are going to get an error. So abstract classes cannot be instantiated, so you cannot create an object for it. Why? Because we have some instance variables which are having no body. So if you have an object, how you are going to invoke them? So that's what you cannot invoke, you cannot create an object for an abstract class. So what we may do is, like, we'll revert it back. So that is what the thing. So in your test case also, suppose if you want to create car object, car is equals to new car, then you're going to get an error. So why? Because abstract classes cannot be instantiated. So now how you're going to access this? But they can be passed as a parameter. Suppose here I have a method, test method. Okay, now here I have a car type, car as a parameter. Now what I'm going to do is, now here I'm going to call car dot, let us say, engine description. I'm just trying to invoke this method. Now the question here is, like, car, I'm abstracting it because car I cannot create an instance of it. So how you're going to invoke this is simple. So we have discussed runtime polymorphism, right? Now simply what I can do is, now I can call test method of Audi and test method of BMW. Why? Because RD is a car and BMW is also a car. So directly you can access it. Oh, the problem is it is non-static. You cannot access. So I'm just declaring it to be static. So when I access this method, now Audi is a car. So on this, engine description will be invoked. So Audi's engine description will be invoked. And second method is BMW. So BMW's engine description will be invoked. To separate this, I'm just writing one statement. So just let us run. Now here I got Audi engine description as a petrol and then BMW engine description as a diesel. So this is what hiding the implementation details. So you're not going to provide any implementation details for your body description or engine description, but you can use your base class as a reference. So if someone passes RD, it is going to invoke that. If someone passes BMW, it is going to invoke that. So this feature is going to be very useful in complex application development. This is how your abstraction will happen. So you don't need to change huge code here. Suppose say here I pass Audi as well, Audi. Now what happens whenever I call Audi only it will invoke. it doesn't invoke BMW. So for this, what I need to do, I need to write a separate method which invokes a engine description of the BMW. Instead of that, what I do, I provide the abstraction where I create an superclass, and then I declare this engine description as an abstract method, and then these two implementations. So you may pass RD, you may pass BMW. I don't need to change the code of it. So this is what one of the huge important topic in most of the complex application development, where you don't need to redevelop the code again if your requirement gets changed. And today I'm using RD, and tomorrow I may use BMW. Example of this is, best example is a database connection. Suppose say today you may use MySQL as a database, tomorrow you may use Oracle as a database. So instead of having all these things, we'll have a base class as a DB connection. So either you pass Oracle DB connection as a subclass, it will give you Oracle connection or something like. So you may have to implement your own implementation for DB connection method. So in that sense, so your application is completely abstracted and can be easily maintained, and all this code can be easily reusable. So that's how abstract classes can be implemented. And here if you see, a Java declared with an abstract keyword is called as an abstract class, and an abstract class may contain abstract method. That is not mandatory that it should contain abstract methods. And one rule is that abstract classes cannot be instantiated. So if a class has at least one abstract method, then the class must be declared to be abstract. So an abstract class must contain at least one concrete class which implements all the abstract methods, otherwise there is no use. So if you have a class which is having all abstract methods and there is no implementation for this, so there is no use. So there should be at least one concrete method which implements all these abstract methods. Similarly, abstract classes are allowed to perform dynamic polymorphism, which we have seen. So an abstract class can be inherited from another abstract class also. So you can perform inheritance. So how we are going to declare an abstract method is abstract public void body color. This we have already seen. And abstract methods cannot be static or final. You cannot make abstract method to be either static or to be final. You shouldn't use. So abstract methods can be overloaded. So you can overload an abstract method, but abstract methods must be overridden in the subclass. So if you want to overload, you can overload. So but abstract classes and abstract methods cannot guarantee abstraction because it may have non-abstract methods also. So that's how we work with the abstraction, and then we have an assignment to work with the abstraction. So go through the assignment and then try to develop a code for it.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
Hello, welcome to another session in Java. In this session, we'll discuss about the last object-oriented programming feature, that is encapsulation. So before going to work with encapsulation, first we need to understand how to work with packages. As we have seen in most of our programs earlier, we were using package as a statement, and then we were giving the package name like com.ZaranTech and then with a complete package name. So in this session, we'll discuss about what exactly is the usage of working with packages, and how encapsulation is implemented in Java, and how you're going to use the access modifier for restricting the accessibility with some examples. And at the end of the session, you'll be having assessment questions and as well as assignment questions. So first, we'll see how to work with a package. So first, what exactly is a package is, generally in our application development, we'll write a lot of classes. Some of the classes will belong to a particular module. Example, when you're developing an application for a bank, let us say some of the classes you have written for admin, and some of the classes you have written for account holder, some of the classes you have written for bank manager. So how do you group these classes together? So in order to have a uniqueness that these classes will belong to a particular admin function, admin module, or these classes will belong to particular account holder module. So you should group them in order to be easily accessible, and then in order to differentiate one from one class to another class. So for that reason we use package. So in technical terminology, if you are defining a package in Java is a collection of dot class files. So it holds the dot class files of both classes and then interfaces. Even we know that interfaces, when you're compiling, you're going to get a dot class file, but interfaces cannot be instantiated, or neither they can be run by using JVM. JVM can execute only the dot class files of classes. So package statement is generally used to define the directory structure. Example, whenever you're working with a particular working space, so when you're creating a class by declaring a package, so the dot class file will be stored under the directory package, directory of the particular statement that whatever you mention. So but there are certain kind of rules to follow for working with packages, because package statement must be the first statement in the Java class. Generally when you're declaring a package can be declared by using a keyword called package, so followed by the package name. So if you have a single directory, you can mention only package followed by package name, or if you have multiple directories or subdirectories by using packages, then you can separate the directory structure by using dot as a operator. So when I say here the example package com.zarantech.admin, and then when I declare class called admin home, the meaning of this is I want my compiler to create the dot class file admin home.class file inside a directory called com. In that you have ZaranTech as a subdirectory, and then in that you have a subdirectory called admin. Okay, and similarly whenever you have another package called student, so there we have package com.zarantech.student. So meaning what happens, what are the classes you have written inside the source file, they will be stored under the root folder com, and ZaranTech will be same for both admin home and then student, but there is a separate subdirectory will be created for student classes called student directory. So these classes will be invoked. Now let us say in my student class I want to use admin home members, so the admin home class should be available to me. So if any class which is there in other package, if you want to use in the package, you have to import the particular dot class file into your package. That import can be done by using a statement called import followed by the complete path of your class. So the complete path of your class will be com.zarantech.admin.admin home. This is how you're going to invoke it. So working with these two, so when you're creating a classes, you should be having only one package statement for a single source file, but you can import n number of classes because there may be different packages you'll be working with. Each package is having number of classes, so and you may use n number of classes in a different package. So when you want to use all these classes inside another package, you have to use import statement. So you can write n number of import statements. So all the classes will be imported to your present class, whatever you're working in the package, so that they'll be accessible. So now we'll see an example how exactly it will be working. So let us say here I have a number of packages. So here I created a package called com.admin. Inside this I have a class called admin, public class admin. We'll discuss about what exactly is this public, private, protected and all this very clearly here. So what is the meaning of this? When I say admin, now I want my admin class to be created inside a package called com.zarantech.admin. And similarly within the same package I have two more classes. One is Chris and second one is John. And similarly I have one more class called student. Inside this I have two classes. One is student and second one is student admin. So let us say here I have student and then here I have student admin. Now here if you see I am using admin class inside the student. So admin is equal to new admin by passing some parameters. So what happens? So this admin, your compiler doesn't know where exactly it is. So you have to import. Suppose if you do not import this, you're going to get an error because it doesn't know where this admin class is. By default, it will check within the same package, or else you need to create an admin class within the same package. So a class, if you have a number of classes inside a package, you don't need to write import statements to import other classes which are there in the same package. but import statement are used to import the classes which are there in other packages. So admin is not there within the student package, admin is there within admin package. So what I can do is I can use import statement. So import statement can be written like this. Or if you want to import all the classes like Chris and then John, so simply we can use com.zarantech.admin.star, or this asterisk symbol will specify all classes will be imported, but that is not a recommended practice because a lot of memory will be wasted. So here whatever the class you are using, that class only you can write an import. Suppose let us say if I am importing Christ, or if I am using Christ inside student, now simply what I can do is I can use zarantech.admin.christ. So this is how you are going to import the individual class. Okay, that's how you work with the packages. Now let us see how these class files will be created. Generally, whenever we'll go to the path of this to demonstrate you. Now here under source, I'm going com ZaranTech. Okay, now here I have admin. Inside admin, I have three. Oh, this is what source I have. So let me go to the bin. So inside com, I have ZaranTech, and then I have admin. Inside admin, I have three .class files. And similarly, I have student. Inside student, I have two .class files. That is what the advantage. If you don't mention these packages, they all will be created directly under bin. So there is no hierarchy actually. That is what the programming practice. So now we'll see how encapsulation can be done. So what exactly is the encapsulation? Encapsulation is a feature of restricting the accessibility of a member in Java. What do you mean by that is, now let us say in our application we have n number of classes, n number of variables, n number of methods. And then each class or each object can interact to other object by invoking its methods, either directly by using inheritance or by creating the instance of a particular class and then accessing its member. But whenever you are accessing a member, sometimes there should be some restriction of accessing the data. So we can restrict the data. Suppose this data can be accessible only to this person and this data cannot be accessible to this person. So how you are going to differentiate which member can be accessed by other members or which member cannot be accessed by other members? So this concept is called as encapsulation in Java. So we declare a particular member of a particular class by using some access modifiers. These access modifiers restrict the accessibility. But generally Java supports 4 access modifiers. One is public, private, protected. Generally speaking 3, only public, private, protected. If you do not mention with any one of this, that is considered as a default. But now here default is not a keyword. Here you should not write default default void main or default integer x. You shouldn't use default as a word for declaring a variable or a method. Why? Because default is already reserved for switch case statements. So when you are using a switch statement, there is a default block. For that we use a keyword called default. So why we are saying default is, if you do not mention any one of the access modifier called public, private or protected, then it is considered as a default accessibility. So the question comes like how these things will be accessible. Or if I declare a public member where it can be accessible, or if I declare a protected member where it can be accessible, or if I declare it to be a private where it can be accessible, or if it is a default which I don't mention where it can be accessible. Generally, when you have lot of package structure, a class can be accessed only in 5 locations, or a member of a class can be accessed only in 5 locations. What exactly are those 5 locations are? The first one is the class members can be accessible within the same class. That is what the first location. So within the methods, and then I can invoke another methods, or I can invoke instance variables, or I can invoke static members. So the accessibility will be there within the same class. That is what the first location. Or any other class within the same class, same package. So like as we discussed in the previous example, like we may have n number of other classes in the same package. So I can access the members of first class inside any other classes of the same package. That is what the second location. The third location is from the subclass within the same package. Within the same package, there may be some subclasses also using some inheritance relationship. So you can access in that location. So within the same package, there are three places where you can access the class members within the same class, within the other classes of same package, and within the subclass of the same package. Now the other locations are in other packages. In other packages, it may be other class or it may be a subclass. So there are total 5 locations where you can access the members. Okay. Now generally a class also can be restricted, okay, by using some access modifier. But for classes, we can use only one access modifier, that is called public. When you declare a class to be public, that is accessible everywhere. Means what? Within the same package it can be accessible, or within the other packages it can be accessible. But when you are declaring a class with default access modifier, it cannot be accessed outside the package. It will be available only within the same package. Now that we'll see with an example. So now here what I've done is, now let us say here I have admin, and for simplicity I'm just creating one more class with a default access modifier called admin test. Okay, I'm not creating any members here, just to demonstrate it whether we can access it or not. Now inside other packages, now I want to access this admin test. So when you're using this, it is not accessible actually. Even though you use import, you cannot access. Import com.zarantech.admin dot what I have, admin test. So now you cannot access this. Even though there is a admin test class, you cannot access this outside the package. Why? Because if you see, there is an error. The type com.admin test is not visible. Why? Because otherwise it is giving a one quick fix available, change visibility of the admin test class to public. That is how you cannot access outside the package. That is what one important thing you'll have. So I'm just deleting this. I don't want to demonstrate this. Okay, let it be. Now there are only 2 access modifiers are available for class. One is one is public, second one is default. When I declare it a public, it can be accessible everywhere. We have seen inside other class also it can be accessible. But when it is default, you cannot access it outside the package. Now let us come to the members. Now here I have created 4 members. One is with public accessibility, one is with private accessibility, one is I did not mention anything, so it is considered as a default, and fourth one is a protected. So these are the 3 access modifiers I have used. Now I have used a constructor to initialize all these values. Now let us say where and all I can access this. Suppose within the same I have a method, I'm writing a method called public void get details. So when I say member, the access modifiers are applicable to instance variables, static variables, and as well as methods. So any member of a particular class, you can use these access modifiers. Now here I say I use public. Now here I'm going to access this admin name and all. So I can access all of them. Why? Because if you see, admin name is accessible, admin password is accessible, admin code is accessible, and as well as department is also accessible. Now let us say admin name and admin password. Let us say this is also accessible. We'll discuss about it. So department and admin code. So when I declare a member with public, first is it can be accessible within the same class. You see inside get details I accessed it. Okay. Now let us see, I have one more class called Christ, or John will say. Here I have a class called John. There is no relationship between John and admin. It is an independent class. Okay. Now here I have admin details, a method. When I have public void admin details, now I want to access the admin details. So I have to instantiate the admin class, right? So now I'm instantiating admin is equals to new admin by passing these 4 properties as a parameter. One is admin name, second admin password, third one is department, fourth one is admin code. Now if you see here within the other class, now I'm trying to access admin name. Admin name I can access because it is public. It can be accessible anywhere. And let us go to Crest. In Crest, I'm using extends admin, so it is a subclass. When you have a get admin details, because it is a subclass, it doesn't require any object here. Simply I can access admin name. Why? Because it inherits all the properties of admin directly in the subclass. So admin name can be accessible. So what and all the locations we can access the public within the same class we accessed, within the other class of same package we accessed, and then within the subclass of the same package. Now let us come back to the other package. Now let us say here I have. Okay. Now what I do is, let me comment this. Now inside other package. So inside other package I have class called student. Now I have admin details method. Now I instantiated admin, and then I can access admin here. Why? Because admin is a public. So then only I can access. Suppose if I don't declare it to be public, then you are going to get an error inside student. See, it cannot be visible. So that is what very important that we already discussed. Now here I have student. Now if I say admin, I instantiated admin.admin name, I access. Why? Because it is public. So within the other class of the other package we accessed. And similarly within the subclass of other package, student admin extends admin. Now admin is within this package. So I imported this, and then I have applied inheritance relationship. Because it is a subclass, it can directly access admin name. So public can be accessible in all these 5 locations. Okay. Now let us discuss about the private. When I say private member can be accessible only within the same class. Outside the class you can't access. Now you see admin password I accessed. But if you go to Crest, you cannot access admin password. You're going to get an error. Even though it is a subclass, you cannot access this. So now it says an error, it is not having a visibility. Oh, sorry, I need to delete this because it is inheritance. Now here we have, okay, that is admin password. Now you cannot access this. Why? Because it is not having a visibility. Okay, there are some kind of suggestions will be given by this. And within the other class, if you see, John also cannot access admin.admin password. You cannot access. Why? Because it is private. Private cannot be accessed outside. Okay, that is how it is admin password. So it cannot be accessed outside. Okay, now that is what private. So even you cannot access it other packages. And the third one is the default. The default can be accessible within the same package. Outside the package you cannot access. Now if I say string department, now let us say Chris is accessing department because it is extending, and then John, if you say, I'm just commenting it out, it is accessing. So within the same package you can access, but outside the package you can't access. Let me save this. Now when coming to here, outside the package you cannot access. Suppose if I give this, it is going to give you an error. Why? Because it is having a default accessibility, or it is asking you to change it to the public. Okay, that's what outside the package you cannot access. What is protected member is, a protected member can be accessible within the same package, but in outside the package it can be accessible only in the subclass. Example, here I have admin code as a protected member. Now admin code can be accessible anywhere within Crest, anywhere within John, because they all belong to the same package. But in other package you cannot access it in student. Suppose say here if I say admin.admin code, you are going to get an error because it is a other package. Okay, now there is no relationship, but in subclass I can access. Now you see here admin code we can access. So that is what the accessibility. So it is one of the very important topic to understand which member you can give an accessibility, which member not. So depending upon that, you have to declare the appropriate access modifier for either methods or variables. Now suppose if you want to access only here within the same class, you can declare it to be private. And if you want to use it anywhere, public, or if you want it to be within the same package, default. or if it is to be within the same package and then within the subclasses of other packages, protected. So it is very important to declare the methods and classes with the appropriate access modifiers in order to provide the security. So this table will demonstrate you if the public member can be accessible where, protected can be accessed where, or default can be accessed where, and private can be accessed where. That is how the encapsulation is implemented in Java. So we have given an assignment, questions, go through them and then try to develop the program.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about one more topic in Java called wrapping. So far we are working in Java with two kinds of data. One is primitives and second one is instances. So each one is having its own importance in Java programming. So far we are working with primitives in order to do some basic calculations on the data types and using the booleans and characters to represent the character data. But most of the primitives are numeric data wherein we can use arithmetic operations or different operations on the primitive data in order to do certain kind of calculations. But object itself is a different kind of data where it holds state and behavior, where you can do lots of operations, where Java is purely programming is written purely based on objects. So Java wanted to be 100% pure object oriented programming language, wherein it has to use everything as an object. But when coming to the primitives are just primitives. They are not used as objects. So there should be a conversion mechanism is required for converting primitives to objects. So that concept is called as wrapping. So the objective of this session is, first we'll understand what exactly is wrapping, and then how we are going to work wrapping, how you convert primitives into objects, and then what are the different wrapper classes are available, and then how you reconvert the wrapper objects into the primitives. That's what you call as unwrapping. And there are two concepts which are introduced from Java version 1.5 called auto boxing and auto unboxing. So we'll see all these things with the examples, and at the end of the session you'll be having assessment and assignment questions. So first, as we discussed, like Java wanted to be pure object oriented programming. So except primitives, everything was written as objects in Java. So Java introduced a concept called wrapping to convert the primitives into objects. Why? Because Java is having a unique framework called collection framework, where it entirely deals with objects. So in some situations we have to use instances, integer or primitive instances into collection framework. So at the time we cannot use primitives in collections. Why? Because they are just primitives. So we have to convert them into instances, then only we can work with the collection framework. So conversion of primitives to object is called as a wrapping. So now if you want to create any object, definitely you require a class. So what Java has designed is, so there are total 8 primitives are there. So each primitive is having a corresponding wrapper class in Java API. So that we can use that wrapper class for converting the primitive to the appropriate wrapper object. So all these are clearly mentioned in the Java API. So if you're talking about byte primitive, it is having a wrapper class called byte. If you see the difference, left hand side, that whatever you have, this byte is just a keyword, but here it is a class. So that's what the difference. Always class starts with a uppercase letter. Now short is having short, int is having integer wrapper class, long is having long, float, double, and again char is having character, boolean is having boolean. So it is having a lot of constructors and methods in order to do certain kind of operations of converting primitives into objects. So first we'll go to the API to understand what are the different classes which are there. All these wrapper classes resides in a package called java.lang, which is called as a default package. So you don't need to import anything. So in encapsulation, we understand that when you're invoking a class which is there in other package, you have to import. But Java provides a default package called java.lang. So if you are using any class in that package, you don't need to import anything. So suppose if you see our workspace always will work in a different package. Example, I have created a wrapping test case class which is there in a package called com.ZaranTech and wrapping. But here I'm using integer wrapper class. But this integer wrapper class belongs to java.lang, but I did not get any import. Why? Because java.lang is called as a default package. So all the classes, interfaces, exceptions, errors, what are there in the whole java.lang package by default available to any package. You don't need to write any import. But other than java.lang, if you're using any class in any other package, so you have to write import statement. That we'll see in the further classes. But now we'll see the API. Now if you see java.lang, now by default you have some wrapper classes like boolean, byte, character, and then double, float, integer, long. So like these are the 8 primitive wrapper classes, the corresponding wrapper classes we have. Suppose let me go to the integer. So when you go to the integer, now it will completely give you the description, final class integer, so you cannot extend this actually. So it is there from initial Java 1.0 and it is having certain kind of constants which will give you the maximum value. So when you are using that integer.max value as a constant, and by default it gives you 2 to the power of 31 minus 1. And then it is minimum values minus 2 to the power of 31. We discussed like what is a range of integer primitive. So these constants are going to give you the value. But if you see the constructor summary, suppose 2 constructors. One takes integer as a parameter, second one it takes string as a parameter. So there are 2 ways of converting, creating an integer wrapper object. One is by passing the appropriate int, and here you can use typecasting. So you can pass byte, you can pass short, which are implicitly casted to int. It's not exactly like an int. So if you have a byte also, you can pass it to the byte. So that it will be created. So you have to be very careful of when you are invoking a particular wrapper class constructor. So when you say integer, int value, so integer primitive can be passed so that it will give you integer wrapper object. Similarly, if you pass a string, it will take string and then will convert into the integer wrapper object. So let us see an example, basic example. So in my main method, I've taken an integer I is equal to 1, 2, 3, 4, 5, and then I have converted it by using the integer constructor. So when I use integer object is equal to new integer of I passed int as a parameter, that constructor will be invoked and then this int object will be created. Now when I print this int object, the value you're going to get is same, but the data type you're changing from primitive to instance. So if I say integer wrapper instance value using int primitive, I got 1, 2, 3, 4, 5. So this is what the output I got. Second thing is we can also convert a string value to integer wrapper object. Example, here I have string int string is equal to 1, 2, 3, 4, 5, and then I have used new string of int string. And when you're converting this, because it is a string, I have a constructor to convert this into the wrapper object. So I got the value. So when you're using this 1, 2, 3, 4, 5, again I got it. Now the question may come, like suppose if it is not having numerics and if it's having some kind of characters, so how it is going to convert now? It doesn't going to convert, it is going to give you an exception saying number format exception. So you should be very careful when you're converting a string into the integer wrapper object. You have to pass the appropriate string value, otherwise you're going to get number format exception. So these are the 2 ways you can create integer wrapper object. And then because these 2 are integer wrapper objects, if you can see, we are comparing these 2 integer instances saying system.out.println int object is equal to int object 1. I'm just checking the equality. What is the difference between integer and primitives equality and then integer wrapper objects equality is equality operator always will check whether both references are same or not. It doesn't say what is a value. Should be very careful here. So int object 1 is a reference, int object is a reference. They both point to 2 different objects. So when they both point to 2 different objects, always this is going to give you false. So when you run this, now you got an output saying that false. Exactly like how the things will happen in object comparison. But how do you check the equality of these two values is you can invoke a method called equals, exactly like how you use in string. Similarly, these wrapper objects are having equals method. So you can see there are a lot of methods you'll have. You'll have compare, compare to, decode, double value. Okay, we'll discuss about this float and all. And now here you'll have equals. So when you have equals method, so which is inherited from here you'll have some inherited methods. So when you're calling that, so by default it is going to compare two values and then it's going to give you the return data. Now when I say integer object dot equals of integer object 1, so by default you're going to get true because the values are same. That's how the equality can be tested. The second thing you'll have is converting integer wrapper objects to primitive. That is what you call as unwrapping concept. So unwrapping is a concept of converting integer wrapper to the primitives. Example, here I have created integer wrapper object. It doesn't mean that I can convert only to the integer into primitive. I can convert it into the any number primitive. Example, I can convert the integer wrapper object to byte, short, int, float, double. Okay, these are the and long. So these are the primitives I can convert to. So here if I say integer object 1 is an int wrapper object which I am converting into byte. To convert it into any appropriate primitive, you have to use triplex value. But here you cannot use char value. So you cannot convert it into the appropriate char value. Rather, you can check these methods, whatever is applicable here. So when you are using here, so you don't have a method called char value. So you cannot convert it into character or boolean. So you can convert it only to the int value, long value, float value, double value, like that. So when I say byte value, the return type of this is byte primitive. So I can assign it to the byte. Similarly, int value will give you int primitive and float value will give you float. So that's how you're going to convert this. So when you're printing the output value, byte value, I got it as 57 because I know that the output is going to be within -128 to +127 only. And in primitive value, I got 12345. Float, I got 12345.0. And when you're using these conversions like wrapping and unwrapping, every time you have to use the appropriate constructor for converting into wrapping and then triplex value method to reconvert it into the primitive, which takes a lot of headache because in certain kind of methods you may use a lot of arithmetic operations. So when you're using arithmetic operations, you cannot use integer wrapper objects. Example, integer object plus plus. Suppose here if I say I have int object, so if I say plus plus, it doesn't have any meaning, but it is having a meaning from Java 1.5, I'll tell you. But on a reference, you cannot perform increment operation, right? So suppose you have a student object. Can I do student plus plus? No, you cannot do because it's a reference. You cannot perform arithmetic operation on a reference. Similarly, your int object 1 is also a reference, so you cannot perform arithmetic operation. In order to perform arithmetic operation on this integer wrapper object, I need to first convert it into int value and then perform arithmetic operation and again reconvert it into the integer wrapper object. So every time you are doing some operation on this instance, every time you have to do unwrapping, wrapping, unwrapping and wrapping, which makes a lot of headache for a programmer. So Java thought it is a great difficulty, and then from 1.5 onwards, it introduced a concept called auto boxing and auto unboxing. What do you mean by auto boxing is you can directly use primitives as wrapper objects. In this case, if you see, I'm going to use this 1, 2, 3, 4, 5 as a wrapper objects. You see, integer wrapper 1 is equal to 1, 2, 3, 4, 5. Syntactically, it is wrong. Actually, primitive is a data type which is having on the right hand side, but left hand side you had object. This is syntactically wrong, but this concept is called auto boxing. It is introduced from Java 1.5. So now when I assign this, compiler understands this int primitive have to create an object and then it will add this value. So when I use this 1, 2, 3, 4, 5, so I got integer wrapper using auto boxing 1, 2, 3, 4, 5. Similarly, auto unboxing. For auto unboxing, what I have done is I created a method m1 which takes int value. Means what? Int primitive it takes as a parameter, and then I'm performing some arithmetic operation. Plus is equal to 100, and then I'm printing value m1 is equal to value. So I clearly know that this method, it takes and then performs operation only on int primitive. But let us say here I have my wrapper object called wrapper1. So when I say m1 of wrapper1, it is completely illegal to pass a integer wrapper object to a int primitive by default. But what Java compiler understands this is, it will convert these wrapper object to a primitive and then will pass this. That is what you call as auto unboxing. Auto unboxing in simple terms, using wrapper object as a primitive. So by default what happens, this method gets invoked and then the value is appended with 10 and then it will print the value. That is what you call as a auto unboxing, which is very important feature while invoking the methods. So here, irrespective of a method signature, whether it takes primitive as a parameter or wrapper object as a parameter, I can pass either of the one, so that Java compiler perform the necessity operation to invoke the method perfectly. So now this is going to be invoked and then I got value in M1 is 12445 because 100 is added here. So that's how auto unboxing is done. So from Java 1.5 onwards, you don't need to use this constructor and this two value method. I mean byte value or float value. Directly you can use wrapper auto boxing and auto unboxing. So there are one more important conversion which is there called converting string to primitive. So far we have seen converting string to wrapper object, but now we are seeing converting string to primitive. And this is very useful whenever you're working with IO, where you take a lot of input from the console, especially in character user interface applications. So any input that you take to your program is considered as a string by default. So if you want to convert it into appropriate primitive, then the wrapper classes are having the parse reflex method. So if you're seeing integer is having a static method called parse int, where it passes string. So it parses the given argument and then gives you a signed decimal integer value. The return type is int primitive, not integer wrapper object. So that's how I have taken integer salary as 1, 2, 3, 4, 5. If I want to convert it into int primitive, salary value is equal to integer.parseInt of salary, where I'm just printing salary and then I got the value salary as 1, 2, 3, 4, 5. So similarly, if you want to convert integer wrapper object to string, then we are calling wrapper1.to strings. To string. Any object, if you want to convert it into string, you can directly use to string. Then one more point will come. How do you convert primitive to string? So for this, we don't have any method in wrapper classes, but we have a static method called value of, which is there in the string class. Okay, suppose integer as a parameter. Suppose I want to pass this salary value to convert it as a string salary string is equals to string dot value of any primitive I can convert. Now I have salary value. So when I do this, now it will be converted to string. So now when I run this, you're going to get the last output as a string, 1, 2, 3, 5 as a string. That's how you'll convert. So this is very important to understand, like what type of data you're converting to what type of data. So based on that, you have different concepts which will be supported by Java, called wrapping, unwrapping, auto boxing and auto unboxing, and that's it. You're converting string to primitive, primitive to string. So these conversions are very necessary in our day-to-day programming. So you should be very familiar, like which type of data you're converting to what type of data. So that's how you work with wrapping. And we have 2 assignment questions and go through them and then try to write the answers.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
So in this session, we'll discuss about a very important topic called exceptions and exception handling. So before going to discuss about exception, we first have to discuss about what exactly is error. And so far we have come across different kinds of errors, which refers to the syntactical problems. So the question comes like, what exactly is exception and why exception comes? If exception comes, how do we need to handle, or how exceptions will interrupt our program? So the objective of this session is, first we'll see what exactly is an exception, and there are different exception hierarchies there. So we'll discuss about what is exception hierarchy, and we'll see what is runtime exception, and we'll see what are the differences between exception and error with some kind of examples. So first, what exactly is a exception is, first you should be very clear with what is error and what is exception. Error refers to the syntactical problem in your code. So when you're not writing any statement according to the grammar of Java or according to the syntax of Java, compiler will give you an error. So when there is an error in the compilation, your program will not run. So until and unless it is compiled without any errors. So as a programmer, it is your responsibility that you have to provide the proper syntax. But the problem here is compiler never execute the code. It converts that into the byte code. So it doesn't know whether the instruction can be executed perfectly by the operating system with the help of JVM or not. It knows only converting this instruction to byte code and then give it to JVM. Once we invoke the JVM with the dot class file, and then JVM start converting these byte code into machine code, and then we'll give the instructions to CPU. Now CPU will start executing the code. So when CPU start executing the code, there are some situations where our operating system could not able to execute the code. So when it is unable to execute the code, then immediately it will raise it as a signal saying that this instruction I cannot process. So that signal will be given back to the JVM, and then the operating system says, boss, I am unable to proceed further because I cannot execute this statement, and then it will send the signal to the Java virtual machine. Now Java virtual machine identifies this as a problem in executing the syntax, executing the statement, and then will refer it to the exception. So that's what exactly is an exception. So to define properly an exception, exception is an abnormal condition which terminates the program flow. So why are we saying this? Most of the people will say exceptions are just runtime errors. That is wrong. Why? Because exceptions may come at the compilation time also. So there is a clear difference between an error and an exception. We'll discuss about the errors, which exceptions which raise at compilation time in further sessions. But exceptions are not only runtime problems or runtime errors. They may come at compilation time also. So to define it exactly, an exception is an abnormal situation which terminates the program flow either at compilation or at interpretation. So generally speaking, exceptions are in two types in Java. The first one is checked exception, second one is unchecked exception. And checked exceptions are occur at the compilation time, and unchecked exceptions occurs at runtime. So the example that whatever I have given, that unchecked exception, it will not be checked by the compiler. So when JVM is started executing, if operating system is unable to process that, it refers to an exception, and then Java deals everything as an object. So what Java people have done is they designed a particular exception classes for each and every signal that CPU generates. Suppose let us say there is an arithmetic problem. If I give you 5 divided by 0, we clearly know that it leads to infinity, and there is no value which defines infinite. So in CPU, arithmetic and logical unit cannot process this instruction. So it raises a signal, boss, I cannot process this arithmetic instruction. So that signal will be sent back to JVM. Now JVM has to deal everything as an object. So they identified this signal, and then they have given a particular class, exception class called arithmetic exception. So JVM creates an object of this type and then will throw to the programmer, and then it terminates the execution saying this is what the exception occurred. So like that, for each and every signal which cannot be processed at operating system, Java is having or identifying it as a exception class, and then is having the appropriate class is defined. So when an exception occurred, what your JVM will do? Your JVM will terminate the execution. It doesn't proceed further. It will completely terminate your program saying that exception occurred. So all these exceptions are created by using an inheritance hierarchy in order to ease of maintenance. So there is an exception hierarchy. The ultimate class for all these exceptions is a throwable. From throwable, there are two derived classes. One is error and then second one is exception. We are more focusing on exception. So there are some derived classes for exception. One is called as runtime exception. This runtime exception is having some more derived classes like null point exception, number format exception, class cast exception. All these exception classes are inside java.lang. And some of the exceptions are categorized. Like if you see IO exception, which is packaged into java.io, SQL exception, java.sql. So like this, these are packaged. So if you want to see any of this exception, you have to go to the API documentation, and then there they'll clearly explain why this problem occurs. If this occurs, how you are going to handle this. That is all about exceptions. So there are certain kind of runtime exceptions, or what you call as the unchecked exceptions. So all of these have taken from java.lang, which are the basics. So we have arithmetic exception, which occurs when divide by zero situation written in the program. And similarly, we have a concept of array index out of bound exception when the array index is more than its size. And we have null point exception when you are trying to invoke a property on a null object. So it throws null point exception. Number format exception we have seen in the previous session, where the illegal number string, if you give, and then it is going to raise this number format exception. Similarly, class cast exception and class not found exception. So all these are examples of runtime exceptions. Each one of them will come at a particular situation. So when this comes, what happens? So directly your JVM will throw these exceptions as an object to the user by terminating the program flow. Then what are the difference between exception and error? Error is generally referred as syntactical problems, which you have already seen, and compilers are responsible for these syntactical errors. So if any syntactical error is there, you have to provide the solution for it. You have to correct the syntax until and unless there will be no syntactical errors in your code. So but exceptions occurs at runtime, and JVM is responsible for exceptions. So some errors occurs at runtime also, which is a subclass of java.lang.error that will say, suppose if you do not provide any main method in your class, so JVM will provide it as an error. There is no exception, because it says exception always will be sent to the operating system, and operating system will give it to the JVM. But here, if you do not write main method, JVM is not going to give the instruction to operating system. So but it occurs at runtime, so immediately it raises it as a java.lang.error. So recovering from error is not possible. Even we use try and catch block for handling it. So, but exceptions can be handled. So we'll see how do you handle the exceptions in a separate session. But in this session, we'll discuss about how these exceptions will be invoked. So for this, I have created a test case, and then here on the first instruction I have written integer 5 divided by 0, and then I'm just trying to print the result. So when this instruction is processed, integer 5 divided by 0, and then you got an exception. It says exception in thread main called java.lang.arithmetic exception divide by 0. At the statement also it will mention in the exception test case dot main method, and at the line number called 10. So here only the exception occurred. When exception occurs, what happened? There are a lot of other statements, but it doesn't execute. When exception occurs, your program will be terminated. So suppose example, we'll see the other exception. Now these I commented, and let us say here I have a class student which I have imported from com.zarantech.to.student, and then here I created it as a static student, and then I want to invoke calculate grade method on the student instance. But student instance is not yet initialized or instantiated. It is just a default value called null. So if you are invoking null.calculate grade, then you're going to get a null pointer exception. Now the question you may ask, like saying, how does a compiler allows you to invoke a calculate grade method when there is no instance at all? That is not the responsibility of the compiler. Compiler always will see student is a reference of type called student. In this student, I have a property called calculate grade so that I can invoke. So it doesn't know whether student class is instantiated it or not. It is not compiler's responsibility. It is JVM's responsibility. For that reason,
this is compiled fine and bytecode will be generated. But when you run this, if you see, you're going to get null pointer exception because JVM clearly knows that this student is initialized only to null. On the null, you cannot invoke a method. So immediately throws null pointer exception. So similarly, let us say I have integer I int 2. Okay, now the size of this array I have given us 2, but when I say I of 3 is equal to 100, there is no index called 3. The index will always 0 and 1. So when I say I of 3 is equal to 100, your compilation will work fine. Why? Compiler always will check about the syntactical analysis. The syntactical analysis of this is I as an array reference of int as an index is equals to int as a value. This is what the syntactical analysis, and according to the syntax it is correct. So it compiles. But when interpretation happens, there is no memory location called I of 3. So when you're running this, so you're going to get array index out of bound exception. It says 3. So suppose here if I give negative value, still compile fine. Why? Because the syntactical analysis in these brackets I need to give only int. -2 is also an int. So compiler compiles, but there is no meaning here. You are going to get a negative array size exception. So like that, there are plenty of situations where exception comes. Now here I am converting string to integer primitive. When I say FDS cannot be converted, here you are going to get number format exception. So let me comment this and then try to run this code. So you're going to get number format exception. So you may have n number of statements which may raise exception, but once the exception occurs, your program will be terminated. It never executes the remaining code. So that is what one of the very important thing you need to consider when you're developing your code. So that's how the exceptions will be raised in your program, and then we'll clearly see how you're going to handle this in the next sessions. There is an assignment. Please go through this and then try to write a program.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
So in this session, we'll focus on how do you handle those exceptions. So the objective of this session is, first we'll see what are the different ways to handle the exceptions, or using try catch block. Try catch block is called as an exception handler, and then we have different ways of using try catch blocks based on your requirement. We have nested try catch blocks, and then we have try catch finally combination, and then we also will have a different exception hierarchy. So we'll see all these things with our proper examples. So in the previous example, we have written a code which may generate different kinds of exceptions. We have seen arithmetic exception, array index out of bound exception, null pointer exception, number format exception. So but out of all these, only one exception will be invoked, and then when that exception occurs, your program will be terminated. So when JVM invokes an exception, or when JVM creates an exception, your program will be terminated, but that's not a good idea to terminate a program in that way. When you're developing certain applications to the users or consumers, so the users may not understand what exactly is the statement, like exception in thread main or something. So you have to handle those exceptions, and then we'll give the appropriate information to the user. So even though when the exception occurs, if you want to execute some set of code, that is what we call as handling the exception. So Java supports try catch block to handle this exception. We call it as an exception handler. So what is the syntax of using try catches? So first we'll write the code which may generate exceptions inside a block called try. So we're just telling the JVM, you try to execute this code. If any exception occurred, because each exception will be created as an object by JVM, we will provide the catch block to catch the appropriate exception. So here if you see the catch syntax, each catch syntax is having an exception type followed by a reference. So when exception occurred, what the JVM will do is JVM will terminate the code from try, and then it will check whether any appropriate catch block is provided for this exception. If that catch block matches with the exception type, then it will execute the catch block code, so that you can execute whatever the business requirements you have inside the catch. That is how basically we'll execute the try catch statement. And there is one more statement called try catch finally. So the finally block is used to handle the code even though the exception is caught or not. So means there may be a situation, example, in my try block I have written a code which generate 3 exceptions. So understanding that, I have written 3 catch blocks for different exception types, but unfortunately my code generated a 4th exception which there is no catch block. So what happens? Your program will be terminated in a normal way. And suppose if you open any crucial resources inside tryback, example some DB connections or any useful informations to the payment gateways or something like, they all will be remained open. So because you always will close them at the end of the try block. So if there is no catch block executed properly, then finally your program will lead with an exception and opening all the critical resources. So finally block is mainly used for this release in code of all these resources. So we just call it as we can write any release code of crucial resources that you open by using try block. So the advantage of using finally block is whether the exception is caught or not, your finally block will be executed. So it doesn't mind whether catch block is executed or not. So if the catch block is executed, still it executes finally block. If the catch block is not executed, still it executes finally block. So there are certain kind of legal combinations we can use try catch finally. One thing, try block cannot be written alone. So it must be used either with finally or with catch or with both. So you can use try catch, which is legal. You can use try finally, which is legal. You can use try catch finally, which is legal. So the third one is the appropriate one to handle the complete exceptions. So we'll see with an example how exactly this can be used. So here in the previous example, that whatever the code I have written, example integer result 5 divided by 0, and this student calculate grade, and then array index out of bound exception and number format exception. So what I've done is I have put all this code now inside a block called try. Now simply I have mentioned try and then I put all this code. And now what I've done is I know as a programmer that this code might generate arithmetic exception. Suppose here when you write 5 divided by 0, it is very clear, but when you say a divided by b, there is a logic. Okay, now what you are trying to do is both the values of a and b you are taking from the user. What's the guarantee that the user cannot give the value called 0? He may give any value. So when he gives 0, then it leads to arithmetic exception. If he gives the appropriate value, it performs a arithmetic operation. So in this case directly I am giving 5 divided by 0. We know that here arithmetic exception will be raised. So actually it will be raised here. So and similarly null pointer exception, and here a array index out of bound exception, here number format exception. So there are chances of 4 exceptions in my code. So what I've done is I need to provide individual catch blocks saying catch of the type called arithmetic exception, and then I provide a reference called E. So when this try code raises arithmetic exception, then this catch block will be executed and then this code will be executed. Now if you want to print the description of the exception, simply you can invoke a method which is there in the exception class called print stack trace. So when you invoke this, by default it will give you the description of the exception, and you can convert this object to the string also if you want to use this as a string, simply by calling e.toString. So similarly I provided one more catch block called null pointer exception and have written the logic. You may write whatever the logic you want to, that will be executed as a business requirement. And then array index out of bound exception I have written, and then number format exception I have written. Now let me run this code, and then I have written finally also. We'll see the different combinations of executing this. Now let us say first arithmetic exception occurred. So when I run this program, what happens? Now I got arithmetic exception is invoked and code to handle arithmetic exception, an arithmetic description. This is what Java that e dot print stack trace, which the same thing you get when your program is thrown by the JVM. Directly it will give you print stack trace and then will print onto the console. And then converting to string, the exception, we use two strings. So once convert, it will be converted to the string saying that java.lang.arithmetic exception divided by 0. And finally block is executed if you see. So here try executed, catch executed, and finally executed. That's how it will be invoked. Now let us say I'll just comment out this code and then I'll use null pointer exception. Now this raises null pointer exception. Now when I run this, now arithmetic exception will not be invoked, rather it will invoke null pointer exception. So the appropriate type will be invoked. So now here the null pointer exception is invoked. Okay, and similarly now let us see that here I am writing array index out of bound code. Now it will invoke the other cache block which we have provided called array index out of bound exception. So when you run this, you're going to get array index out of bound exception. See, it invoked, and then code to handle array index out of bound exception, and then you'll have exception description, and then finally block executor if you see. So similarly we'll go for number format exception. Now here I'll comment out this. So number format exception will be invoked. So any one of the exception which is provided in the try is now properly executed. So that's how the individual cache blocks, you can provide a number of cache blocks, finally is executed. Suppose say in my code I have another -2 here I'm giving, so it gives you negative array size exception, but there is no cache block. If you see, there's no cache block. So what your JVM will do, your JVM will terminate your code. There's no cache block, so it doesn't execute any cache block, but it executes finally. So when you run this, so it says finally block is executed, then exception is thrown. So that is what the main usage of finally. That is how your individual exceptions will be handled. So there is one more concept called nested try catch finally. So what we can do is, suppose the problem with our previous code is here, if any one of the exception occurred, the other code is not executing. If you see here, negative array size exception, so I didn't execute this number format code or whatever. Suppose in this case, if I get array index out of bound exception, arithmetic exception, my other code will not be executed. So what I have to do in this situation, because mostly when you're writing complex business logics, so inside a try you may have a partial code which interacts to database, you may have a partial code which interacts to IO, or you may have a partial code which works with threads. So there may be different kinds of exceptions occurs. So you cannot write the whole code inside a try. What you can do is you can provide nested try statements, and then each try block can have its own catch block. So the same example I have written with nested try catch statement. Now we'll see that. Now inside try I have written one more try saying only integer 5 divided by 0 system.out.println result. So I clearly know that it raises arithmetic exception, but immediately I provided my cache block, so it will be executed. So what happens, first try will be executed, exception occur, catch executed, then immediately I provided one more try, so it is also will be executed. That is the advantage of using nested try. So once I know that this raises null pointer exception, so immediately this catch will be executed, and after that this try will be executed, this catch will be executed. Like that, whole my code will be executed and handled properly. And for this I have provided the outer cache block with exception as a superclass, and then e.print stack trace. Finally I am just going to execute the finally block. So when you run this code, you're going to handle all exceptions by using nested try catch. So you see, this is arithmetic exception, null pointer exception, and then array index out of bound exception, number format exception, everything, and then finally block is executed. This is very important to handle try catch by using nested. So especially this will be useful when your business requirement is very complex and then you are interacting to multiple different environments with the help of try. So and then all these are independent. So when all these are independent, then only you can. So but if one code is dependent on others, if that is not executed properly, probably you need to stop the execution there itself. So based on that, you have to use either nested try catch or the single try catch with finally, and all these things you have to take care. And there is one more concept called exception hierarchy. The problem here is when you're using this, I'm coming back to this single try multiple catch. When you're using this, let us say I have written a set of statements. I know that these many exceptions occurs, so I provide each and every catch block. Okay, now what happens if none of my exceptions are caught? Suppose say here I had a different exception called negative array size exception. When this negative array size exception comes, then let us say I'll comment out this code. When I say negative array exception occurs, now simply there is no catch block, so only finally got executed. Got my point? So I cannot say, like, suppose I have a very huge code, there may be a chance of 150 exceptions. So I can, one solution is I need to provide each and every exception handler for each and every exception. Otherwise, there is a concept, we know that a derived class performs is a relationship to the superclass. So what I can do is, when you provide an individual exception handler with the superclass, so all these exceptions will be executed. Example, now what I'm doing is simply I'm going to comment out all these things so that I don't provide any individual exceptions. Now what I do is I'm going to provide a super exception class called exception E, and then simply I'm going to write one logic called exception occurred in your code, and then you can handle whatever the logic you want to write for exceptions. Now simply I'm just printing the tracks trees to understand which exception occurred. So now let us say first we create arithmetic exception. So now what happens? Arithmetic exception occurred, but there is no individual catch block. Okay, now we'll see what exactly will happen. Will it execute catch or not? Yes, it executed. So saying exception occurred in your code. Why? Arithmetic exception is an exception. So what happens? This derived class I can pass it to as a base class because it performs is a relationship with the exception. So similarly, any exception that is raised in your code, example negative array size exception, now exception is invoked. Okay, finally block executes. Now you may ask a question like, what's the difference between individual catch handlers or superclass exception? Because superclass exception is fine. Why? I don't need to provide individual catches, only one catch which handles all exception. But it depends on your business requirement you have to use. Why? Because if your business requirement is or you need to handle the code based on the exception, there is no option you have to go for individual exception handlers. But if your logic is exception independent, saying whatever may be the exception occurs, you want to execute only one catch block, then at that time you can provide the superclass. But in some situations, you have to provide the individual code for individual exception. At that time, you have to provide. Now the question comes, can I provide a combination of it? Yes, you can provide, but you have to make sure that the catch block, example, arithmetic exception here I have given. So when I say e.print stack trace, here you are going to get an error. Why? Because arithmetic exception is already caught. See, unreachable catch block for arithmetic exception because it is already handled by exception, so that you cannot handle multiple times. So for that reason, what I can do is I can provide it here. So it is fine now. Now arithmetic exception is invoked, and later it doesn't execute exception. Why? Because this catch is already executed. For other exceptions, it will execute this. Example, suppose here I provide arithmetic exception and run your code. So only one catch block executed, that is what e.print stack trace. Okay, it doesn't execute the catch and then finally is executed. Now let us say I provide negative array size. So now in this case it executes exception. So like that, you need to take care about how you are going to handle your exception. That is what single try, a single catch for all the exceptions. So but you have to make sure that whether it is already caught or not. And these kind of questions are very important in certifications. So that is how your exceptions will be handled. and there is an assignment program which has been given. Go through it and then try to write the program.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about a topic called exception propagation. So there is a concept called exception propagation. So in this session, the major objective of this session is we'll discuss about what exactly is exception propagation and then how we are going to handle the exception propagation. We also discuss about exception, checked exception. There's one more type of exception called checked exceptions. In the previous sessions, we discussed about unchecked exceptions, handling them, how you efficiently deal them with exception handlers. And there are certain kind of rules you need to follow when you're working with exceptions, especially in method overriding. So we'll discuss about what are the rules. And there is important topic called the differences between throw and then throws. So, and at the end of this, you'll be having an assignment and assessment questions. So what exactly is the exception propagation? So exception propagation is a concept of propagating an exception from one method to another method. Example, usually when you're developing any complex application, we divide the whole application into methods. So each method will perform a particular task. So usually we invoke all these methods whenever the objects are interacting with each other. We'll invoke one object's method in another object's methods. That's how the objects will communicate, and then that's how your application will be executed. Now, when you're writing a method, you may write different logics. Maybe you may write for interacting with IO, or you may write interacting with your file systems, or you may write a logic to working with the database, or any payment gateways, or any multi-threaded programming. So there will be different functionalities can be written inside a method. So there may be a lot of chances of exceptions. So when exception occurs, and then in that particular method, the execution will be stopped. JVM will stop the execution and then will throw an exception and your program will be terminated. So, but suppose say there is an exception in a method called M4. And then what I'm trying to do is I'm just invoking this M4 method inside and another method maybe within the same class or within the other class called M3. And in M3 I'm invoking M2, in M2 I'm invoking M1, and then in M1 I'm invoking the main method, or in reverse. In main I'm invoking M1, in M1 I'm invoking M2, in M2 I'm invoking M3, in M3 I'm invoking M4. So now when you're this called method invocation, when you're invoking the methods, let us say the exception is there in a method called M4. So but this M4 was called inside a method called M3. So what happens when M4 execution is happening, if the exception occurred, your JVM will stop the execution. But it doesn't say that exception occurred only M4. Now because this M4 method is called inside M3, your JVM will propagate this exception to M3. So it says there is an exception in M4 and as well as in M3, even though there is no exception in M3. So why? Because you are invoking a method in M4 in M3. So because the exception is coming inside a method called M4, so an exception will be propagated to all method chain invocation. So that is what to call as a exception propagation. So it is very important whenever you're invoking other methods or maybe some kind of API calls, you have to be very careful whether it is raising any exception. If it raises exception, how the exception is propagated and then how you can handle it. Okay, now we'll see it with an example. Suppose here I created a Java class called exception propagation. It's a very simple class where I have my main method. Inside main I invoked a method called M1. So I created a public static void M1 method. Inside that I invoked M2. This is very plain example, or you may have a different logic for doing it. But the core concept is when the methods are invoked in a chain method invocation model, and how these exceptions will be propagated. That is what the objective of this example. So in M2, I invoked a method called M3, and I created an M3 by invoking M4. Let us say in M4, I have written a logic for generating arithmetic exception. Okay. Now, when the execution happens, main will be invoked. Main calls M1, M1 calls M2, M2 calls M3, M3 calls M4. Inside M4, the exception raises. When the exception raises, what exactly happens? Now it says exception raised in M4 and also in M3 and also in M2 and also in M1 and also in main. That's how the exception will be propagated. Now let us run this program to see the output. So when you run this, so now we can see the arithmetic exception occurred in line number 16 first. It is propagated to line number 13, that is M3, and then M2, M1 and main. This is how it is propagated. Now the question comes where I can exactly handle this. You can handle this in any one of the location in order to run your code properly. So example, suppose I can handle my code here itself, which is the best practice of handling wherever there is a exception. So simply I can provide this logic inside M4 saying arithmetic exception E, and then here I can write my own logic. Now let us say arithmetic exception is caught. Now when I run this, now there'll be no exception. There'll be no exception. Why? Because the exception is caught inside M4. So when you run this, now because the exception is raised inside M4 and then we are providing try catch block to handle this, so now your exception will be caught. So when you run this, so now exception will be raised here and then immediately it is caught, so that the catch statement gets executed saying that arithmetic exception is caught. So now it is saying arithmetic exception is caught. That's how you handle the exception propagation. So there is one more concept called checked exceptions. Previously, I mean, in all these previous sessions, we were working only with unchecked exceptions. Means I don't need to check them at the compilation time. When exception occurred at runtime, usually your JVM will throw that exception if you do not provide the exception handling with the try catch statements. So if the exception is caught, it will execute the appropriate catch block, and we have seen how this try catch finally will work, especially in unchecked exceptions. So there are one more type of exception called checked exception. What is this checked exception? Is this exception is checked by the compiler before the compilation itself. Now the question comes like, why it has to check, or why these exceptions has to be checked at the compilation time? Is whenever your Java program is interacting with external world, example, you're working with IO, or you're working with database, or you're working with networking programming, or any other external system which is not part of Java or which is not part of JVM. So if your application is interacting with external world, there may be a chance that external world may not respond. Example, when you are working with file system, maybe your file system is not working properly, so that your JVM cannot wait for a long time, right? So similarly, when you're working with a network program, so there may be a situation when you're working in this, that network will not work properly. So to avoid these kind of confusions, or to say programmer, or to inform compiler that I'm going to work with this so and so IO or database, there are certain kind of APIs are created. So when you're invoking any method of that particular class, so it warns compiler that I'm going to interact. I know that there may be a possibility that exception will come. I know about that exception, so I may handle it, or I'm just asking you to ignore it. So compiler always says, but once you are interacting to the external world, boss, there may be a possibility of this exception. You tell me what you want me to do. So then there are two situations. Either I can report that exception to the compiler saying that yes, I know this exception, so that I am asking you to ignore it. That's what you call as a reporting exception. Or I can provide try catch block. There are two ways, but in unchecked exceptions there is only one way. You have to handle the exception with the help of try catch. But in checked exceptions, or you can ignore the unchecked exception, so that your program will be terminated. But checked exceptions must be caught or reported. You cannot ignore them. So to report a checked exception, we generally use throws keyword. Throws is a keyword which is used to report an exception. Now we'll see an example of how these checked exceptions will work. Now for that I have written an example program called checked exception test case. Now here let us say I have a create file method where I have passed, and don't worry about these file operations, we'll clearly discuss in a topic called working with IO, but to demonstrate checked exceptions I'm just taking this IO as an example. Now let us say I'm just using file is equal to new file. If file not exists, I'm just trying to create a new file. But when I'm using create new file, your compiler knows that creating a file may be possible by the file system, may not be possible by the file system. So in order to say this, so we have to there is a checked exception which will be raised by this method called create new file, that is created inside the API. So what we have to do is that is called as a checked exception. It says throws IO exception. So when it throws IO exception, now you have to do only two operations. Either you can report this exception or you can handle this exception. In order to report this exception, generally we use a keyword called throws. So how can I do that? Is there is a keyword I can use throws, and here the exception is coming as IO exception. Now simply I can say throw IO exception. Okay, there are different method invocations. I'll explain you why this problem is coming. So now here throws exception, throws IO exception. Now when I say is that this throws IO exception, this error is gone. So the meaning of this is we are telling the compiler I'm throwing this exception, you just ignore it. If any exception comes, we'll handle it. But there is a possibility that exception may not come. So if any exception comes, then again JVM will throw that exception and then your program will be terminated. That's how you need to do this. Okay, so this throws is a keyword which is used to throw the checked exception, and just we are reporting it. And so there are two possibilities when a checked exception comes. Either you report it or you can caught it. I think you know how to handle this exception with the help of try catch. So there are some rules when you're doing method overriding. There are certain kind of rules you have to follow. Suppose there is a superclass method which does not declare any exception, means what, there is no throws at all. So when there is no throws, what you can do is the subclass overridden method cannot declare any checked exception, but it can declare unchecked exception. The example for this is, let us say this create file, I created a subclass and then I have overridden. Okay, now when it reports a exception, okay, when it reports an exception, one thing is you may report the same exception or you can ignore it. Okay, that is what one point. Suppose if suppose I can write throws IO exception, the same exception I can have, but you cannot throw the superclass exception. Example, suppose if I say throws exception, it will give you an error. Why? Because you can throw any subclass exception, but you cannot throw the superclass exception. That is what the one thing. So either you can ignore or you can throw the subclass exception, not superclass. Okay, so it is always recommended to throw the same exception using throws. Throws IO exception. That is what the general criteria. So when it throws IO exception, again there is a problem. Why? Because you're invoking that in a main method. So this main method either report or has to handle. Suppose if I want to handle this, now I'll say try, and then I can say catch, because I can handle this, catch of IO exception E. So now I can handle this e.print stack trace or something so that the error got removed. This is how you're going to handle these exceptions. So that's what the rule. Okay, suppose if it doesn't throw any exception, okay, if it doesn't throw any exception, you shouldn't throw any exception. Okay, that is how it will. So suppose say let me comment out this. Now you shouldn't throw any exception. Okay, this is what you shouldn't throw, only checked exception. Suppose you can throw arithmetic exception, which is unchecked exception. Suppose I'm commenting out this, but here the problem comes because I'm throwing here arithmetic exception, but here I'm not catching it. So probably what I can do here is I can provide arithmetic exception or something like, or I can provide the superclass exception to handle it. So I can say arithmetic exception. So that works fine. That is what the rules will have. Now there is one more keyword called, now we came to know what exactly throws. Now there is a keyword called throw. Why we use throw is a keyword which is used to throw an explicitly an exception programmatically. Meaning, suppose in some situations I need to terminate my program. Okay, so example, now here you see, if not file exists, I'm just throwing a new arithmetic exception. When I'm saying throw new arithmetic exception, now here when I'm invoking this method sb.createFile of, I created the subclass because the both of them are same. So now I'm commenting out this. Now when I invoke this method createFile, so this createFile method will be called this. Now code to create new file will be executed. But if file doesn't exist, because this file doesn't exist actually, hello.txt inside my D type, so I'm just throwing new arithmetic exception. So what happens, this arithmetic exception will be thrown and then will be caught here. That's how it will be done. Now let me run this. Now you see I got code to create new file and then arithmetic exception is invoked. That is how the throw keyword is used. Throw keyword is used to throw exceptions programmatically. And there is certain kind of differences between throw and throws. Throws is used to report an exception, and then throw is used to throw an exception programmatically. And checked exceptions cannot be propagated using throw, and you cannot do that. Checked exceptions can be propagated using throws, and generally throw is followed by an instance, and then throws is followed by a class. So you can say throws IO exception, but when you say throw new IO exception, that is what the difference. And throw is declared within a method, but throws is declared with the method signature. We cannot say throws inside the method body. So we have to use throws only as a signature, but throw should be within the body. So you can throw multiple exceptions and then you can report multiple exceptions. So multiple exceptions you can report at a time in a method signature, and but you cannot throw multiple exceptions actually. So you can throw only one exception saying throw new arithmetic exception. So that exception will be thrown. So you're not supposed to throw any other exception. That is what the major differences between throw and throws. So there is an assignment, go through it and then try to provide the solution.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about how the exceptions can be created by a programmer, and then what is the necessity of creating an exception, because we have lots of exceptions which is already existing. And then we'll see what are the general important points you need to consider when you're creating a user-defined exception. And we'll again see what's the difference between throw and then throws. And at the end, you'll have assignment and assessment questions. So why we need to create a user-defined exception is, if you consider like when the exception comes or when the exception raised by your Java virtual machine. So the first point is, whenever your Java program or any instruction which is not executed by the operating system, then that situation is called as exception. So when that situation occurs, JVM will throws the exception. So JVM cannot process the instruction, so it throws the exception so that your program will be terminated. Let us understand in a situation like we have seen how the arithmetic exception will be raised. Generally, any number which is divisible by 0, that raises arithmetic exception. Let us say instead of giving 5 divided by 0, let us say I have a program A divided by B. So where I want the user to enter the values of A and then B. So if I write simply integer result is equal to A divided by B, in most of the situations when user enters the data correctly, then result will be generated. But in some situations the user may enter 0. At that situation only arithmetic exception will be raised. So there is no guarantee, it purely depends upon the user input. So likewise, most of the applications in Java will work based on the user input. If user gives correct input, application will work fine. If user doesn't give input, so at that time it is responsibility of a programmer to handle it correctly. So for that reason, there are certain kind of exceptions which will be raised by JVM so that you'll handle them and your program will run fine. But let us consider a situation that in our ATM application, let us say my bank account is having certain amount as a balance. Example, suppose it is having 30,000. So now I went to ATM for withdrawing the amount. Now, so usually you'll undergo through the lot of process. You'll swipe your card, you enter your PIN code, and then you enter the amount, and then it asks you a lot of things like the savings account or this account. A lot of inputs will give, and at the end will give our amount, that how much you want to withdraw. So let us say that I have entered 10,000 rupees. So my balance is 30,000. So usually the application will write a program to deduct this balance after the transaction is successful, and then the new balance will be updated as 20,000. But let us consider in this situation, let us say I have 30,000 as a balance, but user entered 40,000. So in this case, if I say new balance is equal to balance minus withdraw amount, it could be minus 10,000. So there is no exception at all. But here, when the user enters the withdraw amount which is greater than the balance amount, you have to terminate your program there itself. But JVM doesn't throw that as an exception. How you are going to terminate the program explicitly or by programmatically is you have to raise the exception. When the exception occurs, then only your program will be terminated. There is no point of going further if he enters the withdraw amount which is greater than the balance. So in that case, you can terminate your program and display the user, boss, your available balance is just 30,000, so you can withdraw only 30,000, or if you have any cutoff amount, so balance minus cutoff amount. That is what the maximum amount you can withdraw. That's how you have to write the business requirement. So in this situation, there is only one option to terminate your program by raising the user defined exception. So you can raise any exception, but that exception will not handle your logic. So if you want to have your own business requirements when the exception comes, then you have to create your custom or user defined exceptions. So how do you create a user defined exception? Is exception is an object, so you must declare a class first. So you'll create a class, but how you can say it is an exception is it has to perform is a relationship with any one of the exception classes. So maybe it must extend from a runtime exception class or from any of its subclasses. So you can create a class extends runtime exception, you can create a class extends exception, you can create a class exception extends arithmetic exception, or like that, whatever the runtime exception subclasses you'll have. So like any other class, exception class also can have its own business methods. So you can write your own business methods. So first let us see an example like how we are going to create a user defined exception. Now let us say here I created a class called insufficient funds exception extends exception. So what happens, this by default becomes a exception. Why? This no argument constructor by default calls this no argument constructor, so that it becomes by default an exception object because it passes is a relationship. Let us say here I have my method insufficient funds, here I have double amount. So here I'm saying insufficient funds in your account, the maximum amount you can withdraw is this is what the amount, this is what my business logic. So now what I have to do is, based on my business logic, when we are withdrawing the amount, so if the withdraw amount is greater than or equal to the available balance minus the cutoff amount, then I have to raise this exception and then I can also invoke this method. Now let us see how you're going to do that. So here I have written one test case. Inside my main I declared some values. Usually these values will come from your user input, and some of the details comes from a bank database or something. So simply I just created a double balance value as 50,000 and withdraw amount as 60,000 and cutoff amount is 10,000. So in this logic, the maximum amount the user can withdraw is 40,000 rupees, that is balance minus cutoff amount. But the withdraw amount that he has entered is 60,000. So here I have written my business logic saying if withdraw amount is greater than or equal to balance minus cutoff amount. So if it is greater than or equal to balance and cutoff amount, simply what I'm doing is I am writing, let me say here, what I'll do is simply I will throw the exception. So to throw the exception, I first need to create a object. So throw new sufficient funds exception. When I throw this, because it is a user defined exception, when you are using throw, definitely either you have to declare it or you have to catch it. Because I want to handle this exception, I will write it by using try catch block. So now when I say try catch block, now here by default the catch block will be provided. So I'll say e dot, I want to invoke what? I want to invoke this business logic of insufficient funds. So I'm invoking on the reference e dot insufficient funds, but I need to pass the maximum amount that I can withdraw. What is the maximum amount that I can withdraw is balance minus cutoff amount. So this is what I'm going to pass. So when I pass, what happens in catch block, if this logic is true, it is throwing the user defined exception. When user defined exception is thrown, it will come out of try and then immediately catch block will be executed because the reference matches. So on this instance, I'm going to invoke instance method called insufficient funds by passing some value. So this insufficient method will come and then this logic is going to be printed. Now let us run this. So now you see I got insufficient funds. The maximum amount you can withdraw is 40,000, that is 50,000 minus cutoff amount. Suppose if I entered here as 20,000, so this condition is false, so it goes here and then your transaction is success. The new balance will be balance minus withdraw amount. Now it will say transaction success, the new balance is 48,000. So this is how you are going to use user defined exceptions. Okay, so it depends on your logic, business requirements. You can create your own exceptions and then handle those exceptions based on your invocation. So there are certain points you need to remember when you're creating user defined exception. So it is always preferred to extend from an unchecked exception rather than a checked exception. So it's always important to create your user defined exceptions extends from unchecked exceptions, and a catch block should not be empty. When you handle this within try and catch block should not be empty. Why? Because such exceptions are very difficult to track, so you can't handle the business requirement. So for readability, the custom exception class should be having a suffix called exception. So insufficient funds exception. Suppose if you don't declare that as an exception, so somewhere if you use this insufficient funds, you don't understand what this class is all about. So when you say new sufficient funds exception, it will be very readable. So it is important to use your own business methods to handle the exception, and when the exception is thrown, you have to invoke them inside the catch block. These are the important points now. So now you got an idea basically what exactly is throw and then what exactly is throws, even though we discussed it on a previous session. So now you will get a clarity, like we say that throw is used to throw an explicit exception programmatically, but throws is used to report an exception. And checked exceptions cannot be propagated using throw, but checked exceptions will be propagated using throws. And throw is followed by an instance because throw knew the type, but throws is followed by a class like throws IO exception. Throw is declared within a method, but throws is declared within the signature method. And you cannot throw multiple exceptions, only one exception you can throw, but you can report multiple exceptions. That is what the basic difference between throw and throws. Very important interview question. So, and you have an assignment, go through the assignment and try to create the programs for this.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about how to work with IO operations. IO operations are very important and very essential, especially when you're working with character user interface or graphical user interface applications. In this session, will discuss about what are the different IO operations that Java supports, and then how do you handle all these operations, or which package is responsible for doing this, or that package contains what kind of classes, and all these things we'll discuss in this session. So the objective of this session is, first we'll understand what exactly is IO, and then all these IO operations can be done by using different classes which are there in a package called java.io. So far we are not using any other package in the entire Java API. We were working only the predefined Java package called java.lang. So now we are seeing what are the different packages offered by Java API, and then how we are going to work with these kind of packages. So we'll also see how you're going to work with the file operations with some examples. And at the end of this session, we'll be having one assignment question and as well as assessment questions. So first we'll see what exactly is IO. IO is nothing but, in simple terms, we call it as input and output operations. So generally most of the applications are the example programs that whatever we discussed so far, we are not taking any kind of input to the program. We are giving all the necessary data within the methods, and then we are trying to execute the program. So if the method requires the data in main, we declare the data inside the main method, or if the data is required as an instance variable, we have initialized the instance variables, and then we have used them in the program. But most of these data generally we need to initialize based on the user input, especially when you're working with character user interface or graphical user interface applications. So when you are accepting an input from the user, you need to process that input and then you need to generate the output. So far we are seeing how to generate the output in the console with the help of system.out.println. So if you are working with that, system.out.println, out is called as an output stream, so which is used to write the data to the destination. So there are different streams which are used for working with IO. So we'll discuss what are the different stream classes are available in java.io package. So all these IO operations related API is located in a package called java.io. So generally IO operations can be done in two formats. One is in byte stream, or second one is byte IO, and second one is character IO. So byte IO is purely responsible of reading and writing operations can be done in terms of bits. So when you say character IO, the input output operations will be done based on characters. So as a programmer, it is really easy for us to work with a character, but in order to work efficiently with better performance, we have to use byte IO. But character IO internally uses byte IO only, because characters cannot be stored as a characters in internal memory. They'll be stored only as bits, so with 0 and then 1. So obviously whether you work byte IO or character IO, it internally makes use of byte IO only. So Java supports different kind of classes interfaces and a lot of errors, exceptions which are categorized into java.io. So we'll clearly explore what exactly is java.io. So this slide explains you the general basic classes which are generally will use for working with IO operations. The basic class we are going to work with is a file class, which is located in java.io.file. So generally this file is used to work with files and then directories. So this is generally an abstract representation of a file or a directory path name. It doesn't denote that it is a file or a directory. So it just gives only the abstract representation of the path which is specified for either a directory or a file. So file input stream, it used to read the file from a read the bytes from a file, and our file output stream is used to write the bytes onto a particular file. So reader and writer, same, they'll be used for reading the characters and then writing the characters, but in terms of characters. And there's one more important classes that we have is object input stream and object output stream. Generally the file input stream and file output stream or reader and writer classes are responsible only for working with files, that to be the textual data you can write. But mostly in general in Java we work with a lot of objects. Each object is having a lot of state, and then we have clearly discussed about the state, the scope of a particular instance. So the scope of a particular instance will depend upon the location where you're creating it. Suppose if it is in a block, the scope is block. So outside the block you cannot access the instance. Similarly, if you're creating an instance in a method, the scope of that instance is within the method. So outside the method you cannot access. But what if my application is created five or six crucial objects whose state I want to retain it permanently? So you cannot do that. Why? Because objects are always stored on heap. So heap memory will be always collected by the garbage collector. So when the object loses its reference, garbage collector will invoke the object and then freeze the memory. So once it frees the memory, you are nowhere to access the object. The object memory is gone, state is gone, behavior is gone. So in order to store this object state permanently, we'll use object input stream and object output stream. We'll clearly discuss about object serialization later. So but in this session we'll purely focus on how we work only with the files. So generally files are treated as a common source or destination in Java application. Why? Because we read a lot of textual documents, we write data to the textual document, or we access the input from the command prompt or using the keyboard, and then we write the data onto the console. So all these things can be done with the help of file operations. So first, in order to start with, first we have to make use of the file class. So first we'll see the API, like how these are there in the API, how they'll be represented. As we have seen earlier, this is what the API documentation. Here you have a package java.io, and if you click on this, it shows what are the interfaces, what are the classes which are available inside your package. So here there is a class called file. So if you click on this file, it gives you complete description. File extends object and implements serializable and comparable. It gives you complete description what exactly is a file, how it can be used. The file is having a lot of constructors and then methods. Directly we'll go to the constructor area. Now if you see file, we have 4 constructors: file with URI, file with string parent, string child, file with string path name. Usually we'll make use of this, or you'll make use of this when you have given it in the form of URI. So when you're working with the local file system, we always use this constructor to create a file. No, it's not about creating a file, it's about representing the file with the absolute path name. So it may be a directory or it may be a file. So file class is used both for files and then directories, and then you have lots of methods: can execute, can read. So all these things you can go through, and then you can understand how efficiently you can use. The basic operations of file is you can list all the files in a directory, you can create a directory, you can create a file, you can check whether it exists or not, or whether you can see what are the permissions we have, whether the file is readable, writable, or executable. So all these things we can perform with the help of file class. So now we'll see an example how file class can be used. Now let us say I have created a file test case, and then I have created file is equal new file, and then I have created a folder d comma io. This is what my directory. Now whenever I instantiate this, make sure that here no file or directory is created. It is just an absolute path. You have to make sure that it is not created, and then it doesn't even know whether the IO package is IO directory is existing there or not. So simply we are just giving a path. So now here I'm just checking whether is this a file or is this a directory. So I'm just checking file dot isFile method. IsFile method returns you boolean. We can see the syntax here, and now here is your isFile. IsFile returns you boolean. It's an instance variable. It tests whether the file is denoted by the abstract path name is a normal file or not. So, and similarly is directory. So either of the one will be true. So when I run this, it checks whether it is a file or a directory. Now it says is this file is false, is this directory true? Yes, because it is a directory, it doesn't have any extension. Suppose if you give any file under this, then it will say it is a file. It says it doesn't directory. Now we'll see what are the permissions we have for this directory. Is can read. If it is can be readable, it will give you true. It can be writable, it will give you true. Now here if you see can readable is true, can writable is true. And similarly you can list out all the files and subdirectories which are there in this for using a method called list, which gives you all the path names in a string array. So what I've done is string file names, and then this list will give you all the folder subnames, file subfolders, and then file names which are there in the directory. So I have used my for each loop for accessing all these file names, and then I have printed. So if you see the output here, what I got is I have kept 3 ppt files and then 1 folder. So if I can go to that, you can see I have these 3 files, and these 3 and as well as a subfolder. So that's how it is going to list hello.txt also, which is there, which is recently got created. So there are the 4 files and then 1 directory. So I got 4 files and then 1 directory. Okay, now what I'm doing is, suppose let me delete this. I'll just tell you why I'm deleting this now. Now when I run this, I'll get only 3 files and then 1 subdirectory, but I want to create this hello.txt. If you want to create any new file or any directory, so now I have given d/io hello.txt, and make sure here there is no file created. It just checks whether it is existing or not. Now here I'm saying create file dot exists. So when I say exists, it will check whether it is there or not. If it is not there, I'm trying to create a new file. If you remember, create file always raises checked exception. So if I delete this and then if I call create file dot create new file, it raises the checked exception. Either you have to throw it or you have to handle it. So here I have to either add throws declaration to the method, or I need to surround it with try and catch. So I'll make use surround it with try and catch. So now here any exception occurs, it will display, and if the file is successfully created, it will create. So I'll just save this and then let me run this. Once I run, now here you're going to get hello.txt. So now when you run it for the second time, it displays that in the list. So during this time it is not in the list, that's why it did not display. It is created. So when you run the second time, it will be there. So it already exists, so it doesn't create any new file. Suppose if you do not check this, every time if I call like this, create new file, let us say if you run, so you're going to get X. When you run this, so it's not going to be created. File will be there, and when you run this, so file only will be there. So it is always you need to make sure that the file is already existing or not. So it is better approach is create file exists. If it is not existing, you can directly create a new file. That's how basically you can work with the file operation. So this API gives you a lot of methods which you can go through, and then you can understand. You can delete a file, and then you can compare two file abstract path names lexicographically, whether they both path names are same or not, and delete on exit. So all these things are available. You can go through it and then you can find out, is it done, what is the last modified date, what is the length of the file. So make directories, subdirectories if you want to. You can also rename the file to a new file name. You can also set the permissions like set executable, set readable, set last modified, set read only. So all these things you can perform the operations on a particular file. So these are the general methods which we have seen just now, explored, and this PPT, this slide will just explain you these methods, what exactly it will do, and then we have seen it practically as well. So there's an assignment, just go through this assignment and try to write this assignment program.
Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.
In this session, we'll discuss about one important topic in I/O called taking the input from the user. I mean, so far we have been working with only file operations, like how to work with directories, files, and then how to read a file, how to write a file with the help of input stream classes and as well as reader and writer classes. So in this session, we'll discuss about how exactly we'll take the input from the user, especially when you're working in C applications, character user interface applications. So far in any program example that whatever we have worked, we never give any input or we never expected any input from the user. We were giving all the necessary data within the program itself, and then we were working on it. So but usually when you're developing any application, the execution of the application or manipulation of that application always will depend upon the user input. So example, suppose when even when you're developing an ATM application, so there are a lot of inputs the user has to give. So he has to enter his PIN, he has to enter his account type, and he has to enter how much amount he wants. So all these kind of options he has to enter. So based on that only your application will execute. So how exactly we'll take all these input, we'll see in this session. So input to a Java program can be accepted in many ways. Like there are different ways of taking the input from the user. The one way is of using buffer reader class, which is there in java.io package, and second one is using a scanner class which is in util package, that is called java.util package. And then there is from 1.6 there is one more class which is introduced called console, which is there in java.io. So with the help of these three, we can accept the user input from a console application or character user interface application. So in this session we'll see all these things with an example, and at the end of the session you'll be having assignment and assessment questions. So first we'll see buffer reader. So so far we have seen only reader classes and writer classes, like input stream reader and then output stream reader, or like file input stream reader, file output stream reader, and file reader class and file reader class. So when trying to accept any input from the user, there is a class which is responsible called input stream reader. So input stream reader always will take the input streams from the keyboard. So and then it will convert that byte oriented stream into the character oriented stream. So generally buffer reader or input stream reader is capable of reading only one character at a time. So but we make use of buffer reader to read the whole line at a time. Example, when you ask the user to enter a username, you may have 8 to 10 characters or maybe 8 to 15 characters of username. So taking input stream reader with the help of input stream reader, taking this username and reading this will be difficult. So buffer reader takes internally the help of input stream reader to read the whole line and then will return you as a string. So there are different approaches, like as I told you, we can take the input from buffer reader, scanner and console. So in this example we'll see how the buffer reader read line method is used to take the whole line as an input. So for this we'll see an example program, so which I have written. Now let us say the class I have written is called input from console buffer reader. So here I have created buffer reader class instance and then I have initialized to null. So I'll tell you why I have taken it as a local variable, which I did not create it inside it. I'll just let you know. So buffer reader is there inside java.io, so that I have imported buffer reader with java.io.bufferreader. And now inside try block I'm trying to instantiate buffer reader br is equals to new buffer reader. In this constructor we need to pass the input stream reader class. So directly we are passing without any reference new input stream reader, but this input stream reader takes the source of your input. So usually system.out and system.in, these are the two input and output stream classes which are supported by Java, wherein system.in refers to the standard input source, that is your keyboard, whereas system.out refers to your standard output source, that is what your console. So system.in here refers to the keyboard. So we are saying we are instantiated input stream reader giving the input source as a keyboard, and then we have instantiated buffer reader by passing this input stream reader as a parameter. So this is a single line declaration, or if you want to instantiate input stream reader separately and pass that reference, both of them are same. So that's why we have instantiated in a single line. Now let us say here I have a couple of SOP statements. I am saying welcome to student project, and now here I'm saying enter student details. Now from here I want enter name. So for what we are doing like this, simply we are saying string name 1 is equals to, now we ourselves are assigning a particular name called ABC or something, but I actually want this name to be entered by the user so that I will proceed with my operations. So here what my interest is, I'll take all the student information from the console, like his name, roll number, department, and his individual subject marks. And if you remember in object-oriented programming features, we have created a student class. That student class we are just instantiating with the user input, and based on that we are going to invoke the calculating total marks method and calculating grade method. So for that reason I'm accepting all the user input saying enter rule number. So when I say enter rule number, here simply I can accept the input saying br.readline method. Now if you see br or buffer reader is having different methods called read. It can read only one character, exactly like how we have seen the string classes, and it can read the whole character array by passing it, but we are expecting the user to enter, so we can use either read or read line. We cannot pass any parameter here. So read will read you only one character and return you the Unicode number, but read line returns the whole line and return you the string. So this is what we require. But read line method, the return type is always string. So whatever the value you take with the help of buffer reader, readline method will convert that into string and then will return. But if I say the name, that whatever I entered here br.readline, so it returns you string, so I have assigned string name directly. So in the second statement I'm just asking him to enter rule number, but rule number I want it to be an integer. So what I need, if I say br.readline, it will give you string. So but how can you convert a string into integer primitive? So we can use integer.parseInt, which we have studied inside in wrapping concept. So integer.parseInt, by passing this string as a parameter, so which will give you int primitive. So similarly I'm accepting department is a string, so I'm adding it. Subject 1 marks, it's a double, so I'm parsing it to double. And similarly I created 5 local variables to hold each subject marks, and at the end I have is regular student. Here we need to enter true or false. Why? Because it's a boolean. So I'm taking a boolean called regular student, which I am parsing this string to boolean.parseBoolean. so that it will give you boolean primitive. Now I'm making use of the student class which is there in other package, so which I have imported. If you see that I have imported this com.zarantech.oop.student, this is what the student class, and then here the student class I'm just accessing the constructor new student. So if I go here, this is what my student class, and make sure that you make your constructor to be public, otherwise this can be accessible only within the package. The access modifier can be applicable to constructor also because it is its own member. So now to make it public, to make it access in other classes of different packages, we'll make them public. So now if you declare that public, so that you can instantiate that constructor, invoke that constructor to instantiate the object by passing all these parameters. So now what happens, this constructor get invokes and then these values are initialized. So once they are initialized, now I'm invoking calculate total marks which is there in the student class. Now which calculates this and then will give me the total marks of the particular student, and after that I'm calling grade of the student is student.calculate grade, because calculate grade returns you char. So this is what I have invoked. So when you run this program, what happens is, once print all SOP statements, then whenever it finds br.readline, your controller or your JVM will wait till the user gives the input. So suppose here I'm entering so my name and then the rule number as a string, but it will be converted into integer. So you have to make sure, like suppose if user enters any string here, what happens? Suppose say he enters like this, then immediately you'll get number format exception. But here I did not handle, but it is your responsibility to handle this null pointer exception, number format exception. So what you have to do, we are clearly know that whenever you're using parseInt, simply it will ask you to if it gives you number format exception, generally what you have to do is you have to give it like this. So integer rule number, and then I have to make it outside. That is what we have studied, right? So integer rule number is equal to integer.parse int of br.readline. Now here I'll say catch of exception, or to be specific number format exception E, I'm going to say try. Now here I'm saying rule number is equal to integer.parse int of br.readline. If number format exception occurs, now here enters, please enter only integer value for rule number. This is what very specific will do. Now what we do here again we'll say try, or else simply what I can do is instead of try I can say rule number is equals to integer dot parse int of br.readline. So again we are taking the input and then we are assigning. So like that the user will get to know he has to enter only integers. So now when I run this, so now I'll enter my name and then rule number something, so immediately it says please enter only integer value for rule number. So when I enter this, then again it continues, because enter department, and then you'll enter the department computers and enter subject marks, and then you have to be very careful when you're doing this, because I have explained only for one, the remaining things you have to take care actually. So now I'm taking 75.5, 75.5 and 75.5. So now is a regular student, and here we are just using true. So now the total marks of the user student is this much, and then the grade of the student is this much. This is how it will be invoked. So when you are using buffer readers br.readline, so the return type of that is string, and always you have to convert it into the appropriate primitive or any object type depending upon your requirement. So this is the way that how you are going to accept the user input. And then there is second way of using it is a scanner. The advantage of using the scanner class is the scanner class directly accept you the input in the form of integer or in the form of boolean, in the form of double. So it is directly having all the methods to accept the input as it is. So there is no conversion required. Suppose when you want integer, you can directly use the scanner method, scanner class to scanner class methods to access the input as a integer. So now here what we are doing is, now simply we are using scanner sc is equal to new scanner of system.in, and here we are saying enter your rule number. So here I am saying scanner.nextInt. So here we are using next triplex method to accept the data. Now when I say nextInt, it directly gives you int primitive. So I don't need any kind of integer dot parse int or something. So it directly understands the value that whatever is entering, that guy, it has to return as a int. So similarly the name, directly you have a method called next, and similarly you have next double or something. So in this we have taken integer, string, and then double. So we are just printing it, rule number is equal to so and so, name is so and so, fee is so and so. And then you have to be very careful when you're seeing here, after printing this we have used finally here. The finally we have closed the buffer reader. So it is always very important whenever you open any resources, crucial resources, in finally you have to close them. That's what the main use of finally, right? And similarly here I didn't use any try catch and all because it doesn't throw any exception. So directly I have used sc.close, or it is always recommended you can use try catch and then finally. So when I run this, by default it will ask you enter your rule number. So now I entered this 111 and I entered my name, and then I entered some fees as a double. So now it has taken and then it has given the value. So scanner is much more easier way of your taking the input rather than using buffer reader, because you can use a lot of console statements. This is how you are going to take the input. So when coming to there is one more type of taking input called console class. Now console class is introduced from Java 1.6. So how you are going to access the console is, there's a method system class, and we can invoke a method called console, so which directly gives you the console instance. So the console instance, the class is having one important method called read password. So it always will, whatever the user enters the input, it will be in invisible mode, but it reads that password as a character array, and then you can convert that character array to the string. That's how basically we'll use a console class. So these are the three ways how you are going to take the input to your Java program with the help of console, buffer reader and system, and as well as in the console. So you have an assignment, go to the assignment and try to develop a program.
Alright, let's test your knowledge. Here's a question for you. Which of the following is not a primitive data type in Java? Option A, int. Option B, boolean. Option C, string. Option D, char. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, want to master Java programming? Our basic Java course is perfect for you. Learn at your own pace on our platform. In this course, you will dive into Java basics. It's like starting with a toolkit for coding, from simple commands to creating your programs. Our course covers everything you need, from the fundamentals to cool tricks. It's crafted by experts who know Java inside and out. Your instructors are seasoned pros, ready to guide you and answer all your questions. And don't just take our word for it. Our students rave about the course. People like you have found it useful. The best part? It's very affordable. This chance to learn Java won't break the bank. Ready to become a Java pro? Sign up on our page now. For more details, visit our website.